Thank you, Said. Give me 1 second. Can everyone see my screen? Okay. So, hello everyone. My name is Marawin Chheang. I'm a 4th year software engineering major, and the project I'm currently working on for the SURF-IoT fellowship is titled Understanding User Perception of Algorithm Prediction in Personal Health. I am honored to work under the mentorships of Professor Marawin Chheang and Professor Daniel Epstein of the UCI Departments of Informatics, and PhD students Mayara Costa Figueredo. So I would like to start off my presentation with a quick survey. So just by the show of hands, how many people at this symposium currently used or have used any health app or wearable trackers? I think I see a few hands. So look like a few of you who do. So this article reports that 1 in 5 US adult uses health app and wearable trackers. This poll shows that there are 19% of Americans who are currently wears a fitness tracker, such as a Fitbit or a smartwatch, and 19% of Americans who are currently track their health statistic using an app or on a mobile device. As technology with tracking capabilities increasingly becoming more ubiquitous, many people has progressively adopting them to monitor their everyday health. Among the likes of fitness tracking, food journaling, and chronic ill management, women's health tracking is a widely growing field with a market of 30,000 mobile apps and about 50 million active users worldwide who uses these apps to track their menstrual cycle and predict ovulation. However, there are a number of issues in the designs of these apps that cause poor user retention, which led most users to abandon tracking their habit before reaching their goals. So for our project, we're investigating the user's perceptions of algorithm prediction through the context of fertility tracking. And our main research questions are, would users be willing to track personal data when they know the data will not be used to make the prediction? Does knowing the prediction is powered by AI and algorithms influence the user's trust and adoption? And would users like to receive the algorithmic explanation and on how fertility predictions are made within the app? So in order to answer these questions and understand the design of data tracking and algorithmic decision-making technology, we are developing a prototype of a fertility app named Kaya. For the design of this study, we will recruit participants to interact with the app in a device simulator, which is a web application built using React and Express.js framework, and a MongoDB database to log their activity, metadata, and survey answers. So here's a video, a walkthrough video demoing one version of our prototype app. So in order to initialize the study, the participant must read through the instruction, confirm their eligibility, and consent to participate. First, we begin the simulation by asking the user to navigate to the App Store. As you may have noticed, the Get button is disabled until the page is scrolled all the way down. This design choice was made to encourage the participant to read the Kaya app description thoroughly before proceeding to download the app. Then we ask the user to open the app from the home screen and input their first fertility log. And on the input screen, participant has the option to log a variety of personal data, such as their OPK result, period flow, sex, temperature, cervical mucus, pregnancy test result, symptoms, and mood. And after saving their input, the participant is then asked to navigate to the chart tab to complete the simulation and move on to the survey. There are 3 different versions of the app, which is randomly selected for the participant: blank AI, black box AI, and control. Between these 3 versions, there are subtle differences throughout the simulation, starting with the App Store description. The blank AI version has basic mentioning of AI implementation, while black box AI version goes into more details with how the app is using their data to calculate their ovulation period. The control version omits any mentioning of AI implementation. Another difference is the calendar view. While all versions shows the ovulation cycle in blue, the black box AI shows the uncertainty period during the cycle due to the prediction being made by the AI. Furthermore, there's also a difference in the UI copy of the loading indicator after the participant logs their data. This label highlights the difference of system transparency between all three versions as the app is using the data to make the prediction. The study concludes with a survey. Ooh. Sorry, there's a fire alarm. Is there a fire alarm?
Marawin, we completely understand if you need to exit your location, and then you can join later. I would defer the decision to you. Is that
I'm not sure how long this lasts. This has actually never happened before.
okay? How far are you from being done?
About halfway.
Your safety is of importance, and that's the critical first step. So you can, and perfectly okay. We can add you on later to the schedule. Maybe take out some
That
time.
would be good. I can actually go check out if it's actually a fire.
Okay.
I have a question. If it's a fire alarm, you are inside the building, you may be asked.
Actually, it's over. Sorry.
Okay.
Is it okay? I continue.
Yeah. So because
Okay.
if it's a fire alarm, you have to exit the building for the safety protocol.
But I think, yeah, I'm not sure what to do at this point because I don't think anyone's moving. But I can finish this really quickly and then go check it out. But I assume it's just a false alarm.
Okay.
Okay, yeah, sorry about that. Okay, anyways, yeah, so the study concludes with a survey that will covers the user's willingness to adopt, interpretation of result, trust of result, and tracking behaviors. We also asked the user to compare the description of the app that they used with another randomly selected version to determine their understanding of how their prediction are being made in both apps and which app would they prefer to use. So why should society care about it? First, I want to highlight these marketing materials and news headline in regards to personal health informatics. From the increased adoption of fitness tracking devices such as Fitbit, Apple Watch, and critical care devices such as the T-Slim insulin pump, to personal health management apps such as Ada, K-Health, BioBeats, the trend among these technology is the rapidly increase of artificial intelligence in personal healthcare, and they are being led by the growth in available health-related data. These technology will play key roles in strategically and intelligently support diverse medical functions. However, there's a hidden risk of blind trust in these so-called AI black box to perform life-critical functions. This project is also important to me personally because as a type 1 diabetic myself, I'm currently a user of the T-Slim insulin pump. Since I've adopted the technology, it helps me to better control my diabetes and perform day-to-day personal care. However, since my well-being pretty much depends on algorithm, I'm still nervous that one miscalculation can endanger my health. In the context of our study, our goal is to understand the user perception of AI in personal healthcare in order to alleviate this risk of blind trust by increasing transparency. Our intervention focused on the user behavior when dealing with AI technology in life-critical situation of trying for a baby or avoiding pregnancy. Since my mid-program update, we designed a new version of the simulation to study another level of transparency, which is the black box AI. Then we finalized our design and survey questions. I refactored the code to implement more features for the app and deployed on the cloud via Heroku to prepare for our pilot study. My current progress is to improve the current user interface and finalize prototype development and then start testing and resolving any issues that might have come up. And what needs to be accomplished in the future is to start conducting our pilot study within the next few weeks. Then we'll run the actual study in Prolific, which is an online user research tool, and finally conduct our study by analyzing the result and data to answer the research question. To take my project and what I've accomplished to the next level, my hope is to take the result from this study and develop a solution to increase retention in personal healthcare apps. I do believe that tracking your habit is an excellent way to manage your health, and by designing a more personalized experience for the user, we can help motivate users to continue working on reaching their goal. And to conclude my presentation, I would like to again thank my mentors, Professor Daniel Epstein and Professor Yuan Chen and Mayara for providing me support and guidance throughout this fellowship for the past 9 weeks. And thank you to all the Europe and Cal IT faculties for their effort into organizing this fellowship for everyone and their continuous support throughout the program. And last but not least, thank you everyone for listening to my presentation.
Thank you, Marawin. You can stop sharing if you like.
Thank you. Sorry for the fire alarm.
Yeah.
But I think it was a false alarm.
No problem. No problem. Sorry, I have helicopters outside my. Anyway, so let's invite. I want to invite everyone for questions. And maybe I can start with, in terms of the project. So, what was the biggest challenge you've had with this project?
The biggest challenge I've had. So I believe this project started like way before I joined the team. So I kind of adopt the code base that was coded by a former developer. So I feel like the most challenging part is just to go through all the code and see like how it works, and then write my own code on top of that.
Okay. Did you have to read additional literature and be informed of the theme and the topic?
Oh, yes, I do. I do have to read like a pretty good amount of literature to kind of understand like what's the problem we're studying and to what degree should we like take our study in order to like get the data that can actually help solve the problem.
Very good. Any other questions? Dan, I'm sure you're saving a question or two for.
Yeah, I'm typing some feedback to Marawin on another channel, but I have plenty of time to get my questions in.
Very good. Anyone else? Angelo, what do you think? Keep in mind, I want to encourage everyone to engage, and this is the purpose of this gathering. It's not only to present, but to also engage each other and for us to maintain the enthusiasm and the energy. Angela?
Yeah, so you said in your future directions, you just wanted to implement a solution to for user retention. So I was just wondering, like, if you happen to have any other ideas for user retention other than the ideas that you've already implemented.
So I do have a few ideas with, so I kind of like learn a lot about the problems with user retention in these kind of like personal informatic apps from Professor Epstein and Mayara's presentation like a few weeks back on how these apps makes like incorrect assumption of the person, which causes like those users to kind of drop off because they kind of feel like this app is not made for them. So in addition to kind of increase transparency and make things make more sense to the user, I would like to also add more of a implement more of personalization into the app rather than just kind of quote unquote dumbing things down for people. But yeah, more personalization would also help increase user retention.
Okay, yeah, I remember that from Dr. Epstein's presentation earlier, and I thought that was really interesting. So that's cool.
Thank you so much. Okay, and later on in the day, we're going to be asking everyone to reflect on the experience and how it impacted you. So I will save these, open-ended questions to that period. Again, thank you, Marawin. It's my pleasure now to welcome Aviv to share with us his presentation.
Okay. Yeah, do you see it properly?
Yes, perfect.
Okay. Hello, my name is Aviv Benchorin, and I'm a junior computer science major at UCI. I'm honored to be working under my faculty mentors, Professor Dutt and Professor Rahmani, and my graduate student mentor, Sina LaBeouf. My SURF-IoT project this summer has been to help develop the ZotCare monitoring system, working primarily on the wearable and mobile phone side of the system. ZotCare is an IoT-based health monitoring system that is currently being used and tested in the Unite project, which provides health services to pregnant women in underserved communities within Orange County. By utilizing wearables, mobile phones, and cloud services to collect and process patient data, ZotCare allows patients to be directly connected to their healthcare providers. My main role working on ZotCare has been to develop services for smartwatches and mobile phones, aiming primarily to build a mobile app service that remotely updates our smartwatch application and to improve the data collection and file transfers done on the watch. This summer, I've been working with Samsung smartwatches, which the ZotCare system uses to collect patient data. In the system, the watch runs a data collection application that, when started, periodically collects sensor data from the wearer, such as heart rate and stress level. Once the collection period finishes, the app stores the data in a file and pushes the file to a cloud server. For the first month of the program, I focused on improving this data collection watch app. The app originally had an issue where attempts to transfer a data file to the server without internet connection would fail without keeping track of the file, leaving it to be stranded on the watch. To alleviate this issue, I built a background service that scanned the watch for unsent files and attempted to transfer them again, if possible. By running this service alongside the main data collection program, we ensured that no files would get stuck on the watch and create gaps in the health profile of patients. I also worked on adding real-time sleep and activity tracking that would complement the other collected sensor data. Previously, the app only transferred sleep and pedometer data a few times a day, which was infrequent compared to other data that was collected and transferred every 15 minutes to 2 hours. This made it difficult to associate the medical data of patients with the activity states they were in, whether it be sleeping or exercising. While I was constrained by the watch's restrictions on accessing sensor data, I found a way to check and store a patient's sleep or activity state right before transferring the other data. This allowed us to build a more precise health profile for patients and make better informed decisions about their well-being in real time. After finishing these two projects, I tested out the battery consumption of the updated application to make sure it was still acceptable, since having patients frequently recharge their watch would risk causing large gaps in data collection. The graph on the right shows the battery consumption of two different variants of the app that are being used in different studies. The x-axis represents the amount of time that the application had been running for, while the y-axis represents the battery life that the watch was at, starting at 100%. As the trend lines of both apps show, the battery consumption of the app was relatively consistent throughout the runtime, and both apps were able to run for almost 2 days, which is reasonable for smartwatches and deemed acceptable. My main project during the program, however, was to develop a software update service that could update that watch data collection app through a mobile phone. The default method of updating the watch involves using a command line development tool, which would either require asking patients to update the watch themselves on their computer or send the watch back to be updated. Our goal for this update service was to be able to easily update the watch through the patient's phone when needed, with minimal user interaction. To update the watch, the phone would need to connect to it, push the update file to it, and then ultimately instruct it to install that file. To take these steps, the update service needed to follow the protocol that the watch communicates with. Thus, I had to reverse engineer the protocol from the development tool's source code so that I could implement it in my own code. I spent a lot of time researching the source code, charting out the interactions between the development tool and the watch. In order to keep track of the protocol messages being sent between the two devices, I built sequence diagrams that mapped out the source and destinations of sent messages, as can be seen in the diagram to the left. The diagram illustrates how, when the user inputs the command to connect to the watch, the development tool creates multiple threads to try and handle the connection request, which communicate with each other while talking to the watch. This development tool, which was designed to handle connections with multiple devices at the same time, had a much more complex implementation of the protocol than was necessary for the update service, which just connected one phone to one watch. Once I better understood the communication protocol, I was able to prototype a version of the update service in C, eliminating any unnecessary functionality, such as the creation of multiple threads here, and replacing code that I thought would have been incompatible with mobile phone operating systems. Once the prototype was complete and worked properly, I started to port the service to Android. At first, I tried to directly use the prototype's code in Android using the Android native development kit. Our goal was to have the prototype be a portable service that could be used in both Android and iOS apps, which would have made it easier to maintain the service for both operating systems. However, using this prototype code was unsuccessful due to communication issues between the update service and the Android environment, especially when trying to connect to the watch itself. Ultimately, the solution was to recreate the prototype in Java to eliminate the risk of any incompatibilities. The good news is that with the existing sequence diagrams and streamlined prototype, it was straightforward to make the transition from C to Java, since I already knew how to implement the communication protocol in its entirety. I was also able to take advantage of rewriting the code from scratch as an opportunity to further remove any superfluous code and functionality. The diagram on the left displays the full communication protocol the phone app has with the watch. Once the user presses the update button on the app, the phone and watch can exchange their messages, with the phone first requesting to connect to the watch, and afterwards pushing the update and installing it to the watch. Here's a demo of the latest version of the Android app, which can successfully install an application from the phone to the watch and is a large milestone for the project. After the user inputs their watch's IP address to the app and presses the update button, the watch will bring up a prompt asking whether to accept the connection. If the watch accepts, the phone will start trying to push the file to the watch and attempting to install it. Once it installs, the icon will appear on the UI, as we will see here, which shows that the app has been successfully installed. And when you open it, you can see that the data collection app is actually on the watch. The large-scale societal impact of the ZotCare system is that it has the potential to significantly enhance the healthcare services available to underserved groups, as well as reduce healthcare costs. The benefits of systems such as ZotCare are even more important now during the pandemic, as many individuals are either losing health insurance from their employers or are facing increased financial insecurity, making healthcare even less affordable and accessible than before. I feel that my specific work also has had an impact. Being able to remotely update the smartwatch is crucial for giving patients the best healthcare experience possible, as future improvements and new features to the watch application can be implemented without a potentially harmful delay. As well, by adding more functionality to the data collection and file transfer services on the watch, I help to give more consistency and depth to the patient data available to health providers, allowing them to more thoroughly refine their patients' health profiles. With the completion of the Android-specific update service and the prototype Android application, the next steps for the project would be to port the update service to iOS and ultimately integrate both implementations into the existing ZotCare mobile app. Another potential addition would be to expand the interactions that the watch and phone can have over Bluetooth, and enabling two-way communication between the devices, an example of which would be allowing the phone to trigger different activities on the watch. I would like to express my thanks to Professor Dutt and Professor Rahmani for the opportunity to be working under them on this project, and also like to express my thanks to Sina Laboff for guiding and mentoring me during this time. Thank you.
Thank you, Aviv. Questions? Melinda, I can tell you have a question.
It's not. There's quite a few things that I'm very impressed about with the project. I had to step out for a little bit, but I had a question about. So, were you able to make the the entire connection? So, did you make it from scratch yourself, or was there like existing frameworks or libraries that you used to make it?
So in regards to like the original prototype, I was able to use a lot of the development tool, which was in open source, like to be able to use a lot of the different implementations of that service in the code, just trying to remove all the things that wouldn't work on a phone. like it was creating multiple processes or doing weird threading issues or weird threading stuff. So I was able to, I had that available code base of the original program, but and then when moving to Android, like when trying to rewrite all of it in Java, thankfully there was an adjacent library that implemented the same protocol, but meant for a different program, like a different tool. So I was able to kind of utilize that tool, at least parts of that tool, to help not have to rewrite everything from scratch, which would have taken quite a while.
Okay, fantastic. Thank you.
Any other questions?
I just want to, again, thank Aviv. Excellent job. And the work that you've done has already, as you mentioned, has already impacted the project. We're using this update service, and it's been a big help. So thank you for the nice work and the presentation as well.
Thank you.
I very much agree with Professor Dutt, and I'm really quite impressed with all of you. And Aviv, you bring this level of maturity of and confidence. And how did you become this way?
That's a very tough question. I mean, there's no answer to it. I'll say that throughout the work, throughout the time, there's of course periods where it was frustrating when you hit that roadblock of, oh, why won't this work? And it all just boils down to having the patience to say, eventually something will click and you'll be able to find the answer with enough time and enough searching. So it's just about being willing to give yourself the time to process and let things settle before deciding that something's impossible.
Thank you, my friend. Well stated. John, are you ready?
Yep. Share my screen.
The platform is yours.
Okay. Do you see my presentation?
Yes.
Okay. So my name is John Lee. I am an incoming fourth-year student in CS. I'm working for the project Mobile and Webapp for ZotCare under faculty mentor Niku Dutt, and my graduate mentor is Sina Labaf. So the main goal of this project is to provide medical services to underserved pregnant women in Orange County. There's a diverse cast of community members supporting this goal, including community outreach, doctors, medical providers, nurses, researchers, and developers. On the developer side, I'm mainly working on the admin application and user application. With the user application, I'm more concerned with the questionnaire design and creation. While the admin application, I'm mainly working on the dashboard with data visualization. So why society should care about it? It'd be a really good alternative to current health practices for pregnant women, especially now. So typically a pregnant woman goes to their doctor every month to every week for checkups concerning maybe their health and the baby's health. Usually this is like tracking like blood pressure or something like that. We aim to reduce this with this project by introducing IoT devices that can track health information, such as with two of the ones we have right now are the Oura Ring, which is featured in the NBA, and the smartwatch. Using these two tools, we can help reduce costs simply because we would reduce doctor visits, because since the doctors can get this information on a day-to-day basis, they don't need to check up as much, but also increase doctor efficiency. Since they have this information to a day-to-day basis, they can react faster if something odd comes along. This web platform or mobile platform also allows a platform for communication. Without this platform, users wouldn't be able to contact or use their devices to provide the information to the platform, while doctors and medical providers wouldn't be able to access this information from these IoT healthcare devices. Finally, it allows for easy data retrieval and display. Whenever these users give their information over to the platform, we display it in a nice chart. So current progress done. Like I said before, on the user side, I'm concerned with the creation of surveys. Recently, I've been working on a survey that's based on trying to know how lives are for pregnant women during COVID-19. It spans around 12 pages long and recently passed its RB trial and will soon be passed around to be taken. Other progress done. So I've been working mainly on the web app side. So there's been a lot of web app improvements. One thing is enhancing user administration or user registration on the admin side. So whenever, so typically the admin or researchers are registering new users quite often. However, they started to show a tendency of using the same password over and over again. Nice and convenient for them to just click on and get a new password, and that's fairly secure, and also introduced a new password strength monitor. Other things I did, I've been working on some bug fixes. A good example of one bug fix I was working on would be this specific question. So it's a checkbox question that is required. So typically when you see this online or something, you would think, oh, I'm gonna check off at least one in order to bypass to the next page on the survey. However, there was a problem where if you clicked one and you unclicked it off, it would let you bypass the survey anyway. This problem was later fixed, I think, in the middle of the SURF-IoT session. So other progress done, I've been working on a new survey feature. This one was recent, where it's a little cut off here, but it's a matrix format where you have some headers, header categories, and then you're able to click on these buttons. Another thing I worked on is this new event page. So let's say there's an event that a researcher or medical provider wants to track. I'll just give some examples. So there's a sensor trigger. So let's say that since Aviv's products are working directly with this web software, let's say that the blood pressure is a little low and you want to track that lower than usual. So you click on this, click on a certain sensor that you want to track, label out the conditions that you want to track, pick out if it's an email or notification, then save it. And if that blood pressure is like lower, then it will send over whatever you want, like the email or notification that you saved. There's also a prompt trigger. Let's say that a user answers a questionnaire in a certain way, like let's say maybe, oh, they answered yes, I had COVID-19 before. Maybe that's something that we want to track, right? So then we would click on the prompt, pick on the certain questionnaire, pick out the condition maybe for the question. So if the question is answered yes, and then click email or notification, save. If a certain person answers the questionnaire in that way, they'll send an email or notification over. Lastly, I've been working on a cron tab trigger as well. Cron tabs, the best way is to give is an example. Cron tab is basically you want to trigger it, a notification email at a certain time or day. So let's say you want to do it every Monday at a certain time, like 9:30. Cron tab can do that. It's a little complex since it's just basically all numbers, but simplistically, if you want a specific time or specific day to be reminded every week, you can do that with cron tab. Other things, I've been working on a lot of logistics, just a lot of communication stuff. I've been communicating with Sina a lot on just a survey and all these features that I've been trying to add. And then I've been going on Gmail a lot, contacting the professor about the creation of surveys, but also reaching out to past interns based on the completed work and asking questions about it. Future work, I imagine there's going to be a lot of more integration with IoT devices to the application, just because we only have 2 right now, and I imagine we would want to expand. More questionnaire types, because the current set of questions we have is rather low and it's not a one-size-fits-all. Adding a preview button to these surveys. A good example is that Caltrix has it, but our application doesn't have it, and we would like to have that because it allows you to see like what the survey looks like and fix up any errors before you publish. And since I've been working mainly on the website, this is also a mobile application as well, and there are iOS bugs that I should be fixing, but I'm currently working on the web. And then with more IoT devices, there's going to be more data visualization. Yeah. I would also like to thank Nick Yuda. He I emailed him during the start of the session for interest about this specific project, and he very explained about what I do. And I'm very thankful for having this opportunity and getting accepted to this program. And also I'd like to thank Sina LeBeouf because he's been very patient with me, and he's been teaching me a lot. Any questions?
Thank you very much. You can stop sharing, John, if you want. Any questions, please?
I can ask a quick question.
Mm-hmm.
So in terms of when you talk about like for future updates having the data visualization,
Yeah.
is it going to be more in terms of like the raw, like visualizing the data or trends in data like from the IoT devices, or would you also like would it also be for like the survey results, like doing that type of?
Yeah, we do both. We do both.
Okay.
So you can pick out if it's like a certain sensor or a certain prompt or questionnaire question. You can track all that.
Okay. Have there been any thoughts of allowing like patients to also visualize their data, or do you think that would be more exclusive to just like the healthcare providers or whoever's in charge of the admin side?
I haven't reached that part yet because I've been mainly working on the admin side. For the user side, it's mainly like showing, doing the questionnaires and stuff. Although I imagine that we would probably want to do that because it'd be really nice for them to see. But I'm just not completely sure because I haven't explored that part yet.
Okay, that makes sense. Thank you.
John, I'm curious, how did you expand your skill set as a result of this project?
So I expanded my skill set because I've been working on other web development languages. There's PHP, Laravel, React that I've been familiar with. This is an entirely new not entirely new, but it's a different structure than the other web development languages that I learned. And it's really helpful for me to learn this simply because it's new and it's very up and coming. And I just wanted to be really familiar with it.
Thank you again. Both you and Aviv and all of you are lucky to be working with wonderful mentors who have been committed to working with students for years. Professor Dutt, do you want to say anything?
Can I say just a word? I think, John, thank you again. I think, all of you, you've been doing really important work. John, your work has also been very crucial where we're trying to send these questionnaires out in this very difficult time. And, Aviv, you had some excellent questions about the dashboard. This is a very complex project, as many of you can surmise. There's so many moving parts, and the quick answer to Aviv's question is yes, individuals should own their data and they should have access to their data. That brings a whole host of engineering problems in terms of how do you make sure that the right views are in place, because the dashboard in some sense is a front to the entire repository of everyone's data. And so, yes, I think there is a long-term goal of doing that. But in the short term, I think the project is focused on making the data available to them through their devices separately. And I think in the long term that would be, but we can take these questions offline. But I think that's of probably interest to everyone, because in this era, I think, the model should be that you should be the owner of your own data, and you should be giving access to people based on what you feel comfortable with. Thanks for those questions, and thank you both again for really good work.
Thank you, Professor Dutt. These are great comments. Very well. In the interest of time, I'm going to turn it over to Jonathan.
Hello, can you hear me?
Yeah.
Let me share this. All right, can you see this? Okay, I'll just get started then. Hello, my name is Jonathan Sugijoto, and for SURF-IoT this summer, I was under mentorship of faculty members Professor Dutt and Professor Ramani, and also under the mentorship of graduate student mentor Milan Oskari. So what I worked on this summer was continuous blood pressure monitoring with the use of smart devices available commercially. So as we all know, wearable smart devices are becoming more and more popular for people to be using every day in order to track their fitness and their health, And a few examples would be stuff like Fitbit, Oura Ring, or even Apple Watch. And they can all measure all sorts of vitals like your breathing, heart rate, your steps taken, calories burned, and even sleep quality. So the most important sensor for me and these devices, though, is their PPG sensors. So what is a PPG sensor? PPG stands for photoplethysmography, and it measures the amount of light that is absorbed by blood vessels, which translates to the amount of blood in the path of the light. This means that we can detect how much blood is going through the optical sensor at a time. And why is this useful? It's because we're able to detect heart rate, so heart rate, respiration, cardiac output, and most importantly, we're actually able to extract blood pressure from it. It's also a super cheap technology to create, so it only requires a little light source and a photodetector to make it work, making it super convenient for continuous measurements. And on the left side of the screen, you can kind of see a perfect PPG measurement and get the general idea of what the segments look like with their first peak, and then it dips down to a valley and peaks again. So I'll show a labeled graph later of the actual features of the signal that you can look at. So what was our goal this summer? We wanted to have continuous blood pressure monitoring using only the PPG signals that come from smart devices. And as a general overview of the project, it would be pipelined as we take the PPG signals, pre-process them, we would extract features from them, and then we would need to design and train some sort of neural network. And then after that, we would take that blood pressure information to categorize the blood pressure into different zones. So like maybe a risk zone, safe zone, or whatever. And we wanted to specifically apply this to pregnant women. And as far as I know, there is no continuous blood pressure monitoring system available commercially. So most people would be working with something like this at a doctor's office, which is just a regular blood pressure cuff. And these cuffs are actually the gold standard for blood pressure monitoring, but they do have their drawbacks from the fact that they're a one-time measurement, and they're relatively uncomfortable, albeit for a few seconds when you're compressing your arm. And you also have to be at rest for a little bit in order to take blood pressure accurately, unless you want to get your blood pressure while exercising, because when your heart rate goes up, your blood pressure will also increase. But most people don't even have one of these. At best, they might have one of these, which is a digital blood pressure cuff, and it'll automatically find your systolic and diastolic blood pressures for you. But this is also kind of out of the way, and most people wouldn't want to use something like this. So we're just going to try and use something that a lot of people are starting to have now, which is the Fitbits or the Oura Ring and the Apple Watch. But the one problem with these is actually when you take the signals from them. So the one drawback of using these smart devices is actually caused by the convenience of them. By putting them on our wrists, on our fingers, like in the Oura Watch, we're putting it on one of the most mobile parts of our body. So when you take these PPG signals from them, you won't actually get a very good signal. They're not going to be very noiseless. They're going to have a lot of motion artifacts and a lot of noise. So the first part of our research here was to take these signals and be able to filter them. And so to complete this, we just use some simple bandpass filters to remove the high and low frequency noises. And we also normalized the signals to not work with signals with the amplitudes in the millions. So as you can see, we went from the left unfiltered PPG signal, which was kind of unruly, no consistency at all, to the right signal, where you can have the PPG signal, and it's really easy to distinguish the extrema, the intervals, even the minima. For feature extraction, we wanted to take features of the PPG signal that would relate to blood pressure. And let's look at the regular PPG signal first. So we would take the ideas of the systolic peak, which is at the first peak, we have the dicrotic notch, and the diastolic peak. And taking these into account, we wanted to take these features that are correlated to some sort of relation to blood pressure, maybe systemic vascular resistance, your peripheral resistance, or even your heart rate. And the four features that we ended up choosing were systolic amplitude. So we have just the magnitude of the systolic amplitude. We have 50% pulse width. So at 50% of the systolic peak, we would take just the width of how long it would take for the wave to propagate through. We have peak to peak interval, which is relatively self-explanatory, and pulse interval would be the minima to the minima. For the difficulty of feature extraction, I just want to note that there are other journals who have been doing feature extraction here, but most of them have been working with perfect PPG signals. So if I go back to this one, they would be using, all the way, they would be using signals that are perfectly defined. So you can see the systolic peak, the dichrotic notch and the diastolic peak. But when we process our signals here, we would not get the diastolic peak nor the dichrotic notch. So this would actually reduce the amount of features that we can kind of extract from it. But kind of a general way that we got around it would be to look at the estimated second derivative of the PPG wave. And that would be on the bottom right here. And since it's estimated, it's not going to be a smooth graph. But if we look at the maxima inside of the range from the green to the red dots for all of these, we would get a maxima and kind of see where exactly the inflection point for the PPG signal would be. And we can use this actually as a relatively good estimate in order to estimate where the dichrotic notch and the diastolic peaks are. For the other features like the widths and the extrema, we just use simple peak detection algorithms. So we needed to play with it a little bit. There are a lot of open source ones, but we just needed to tweak them just enough so that we could only get 1 point, 1 maxima, 1 minima. And for the 50% pulse widths, we would just take the midpoints and find the distance between them. Yeah, so moving on from that, once we have our features, we can actually try and take these features into a neural network. And so we needed some data to train off of. So we got our data from UCI's machine learning repository under the cuffless blood pressure estimation set. And that provided us with arterial blood pressure signals and also your PPG signals in real time. So in blue here on the right would be the arterial blood pressure, and on the orange would be the PPG signals. And one thing to note about this is that the maxima of the arterial blood pressure would be the systolic blood pressure, and the minima would be the diastolic blood pressure. So we could take this information and extract it using the same peak detection algorithms that we use for the PPG signal, and we would have a systolic blood pressure and a diastolic blood pressure for each of the PPG waves. Yeah, so once we were able to extract all the features we needed, we were able to create a very simple neural network, and we could test if the model was able to train off this data. So we were able to train our model to have around a plus or minus 5 millimeters mercury error for the systolic and diastolic blood pressure, which is relatively accurate, but we would like to get more accurate. So on the bottom left, I have a metric. We were using mean squared error, so the mean absolute error would be, as I said earlier, a little bit over plus or minus 5 millimeters mercury. And as an example of what the model would kind of output given a PPG signal, we would have a systolic blood pressure on the left and a diastolic blood pressure on the right. And this is kind of what we would see as the output here. For future work, I think we still need to work on improving the neural network. We can test whether different types of layers, different amounts of layers and neurons would change the improvement of it. And we could work on this. I also only trained the neural network for around 30 to 40 epochs. So it wasn't a very long training session, and we could definitely use a lot more data points from the repository. We just used a preliminary test first. We can also work on feature extraction improvements. So we could, like I said earlier, we could try and find the actual values of the dichrotic notch and the diastolic peaks instead of trying to use an estimation for both of them. And then we can also add different features to the data. Right now, we couldn't really take out some of the features because of the fact that we didn't have the dichrotic notch or the diastolic peak data. So there are other features that correlate to blood pressure that we could add to this. Later on, we still need to take the blood pressure information and classify the different zones of blood pressure for pregnant women. And then we wanted to optimize these readings specifically for exercise in order to watch the exercise intensity for pregnant women. Lastly, I'd just like to take some time to thank Professor Ramani, Professor Dutt, and Milad Asghari, my faculty and graduate mentors, for guiding me through this project this summer. And I'm deeply honored to have had a chance to work on this, and I look forward to continuing to work with everyone. Thank you.
Thank you, Jonathan. I invite everyone to ask questions.
I have a question.
Please.
So have you ever had to work with a PPG signal that was so unruly that no amount of pre-processing would allow you to identify the artifacts that you mentioned? And then if so, what did you have to do?
Yeah, so we would actually just reject those signals. If they're that bad, you can't salvage them, and it's not possible to go any further with it. So we would just reject those signals and continue on with the relatively better quality ones that we would go with.
Okay. So you never asked patients to like re-measure their PPG signals or anything?
Well, the general idea of this was that we wanted to make sure that we had PPG signals from smart devices. So we would need to take into account that people are going to be, I don't know, running or working out with these Fitbit devices, and that would make a lot of noise in the signals, right? So we needed to make sure that we can do that.
Okay, thanks.
I'm curious. So let's say you detect an abnormality in blood pressure. How would you give, what type of intervention, or how would you give feedback to the subject in this case?
Right now, we were planning on just taking the blood pressure signals, and if they're in like some sort of danger zone, maybe your blood pressure is too high and you're working out too hard and you're at risk of maybe like exhaustion or something like that, we would throw an alert to the phone or even the smart device itself. So that's all we have right now. I was just working on the blood pressure monitoring right now, but it will be parts of a project later on.
Excellent. You know, these projects are so exciting because, I mean, yes, there's coding and there's software, but it's also touching on real life issues and other disciplines. Professor Dutt, you want to add anything?
Thanks, Jonathan. Excellent presentation. And, you know, just to answer, I think there were some good questions. One of the challenges, and I think Professor Epstein also discussed that, one of the challenges we have is in this healthcare IoT wellness area is how do you make things affordable so that people can actually use them in their lives, and B, in what we call as everyday settings. So you saw a prime example of that at the beginning of Jonathan's presentation, where, you know, the traditional model was you go to a nurse's office or you go home and then you pick up a device and then you have to physically do something to monitor your health. And the paradigm shift is, can we make that ubiquitous, kind of under the hood? And so I think the kinds of things that you saw in these projects is in that direction. And related to that is Saeed's question, you know, so what happens if there's something wrong? And there are different modalities for doing, you know, handling that. One is, of course, to alert the user or the person. And if it's really serious, then the alert needs to go to a healthcare provider. So those are kinds of the things at the top level where, you know, that's part of the studies that we'll be doing to see, especially if we're looking at pregnant women, for example, if they're exercising and their heart rate gets really high or the blood pressure gets really high, then you do want to alert medical providers. So those are kinds of things that we're developing in the protocols. And so very exciting research that you guys have done over the summer, and thank you again for all your efforts. And hope if you have time, hope we will continue doing work with you guys.
Again, we're so grateful to you, Professor Dutt, and congratulations to all of you for the wonderful work. And as we said earlier, the journeys continue, and there's still more exciting work to be done, and hopefully you'll realize the impact and the benefits. Thank you, Jonathan, again. Judith?
Can everyone see my screen?
Yes.
Okay, perfect. Okay, so hello everyone. My name is Judit Castellanos. I'm working on the project Pain Buddy, treating pain in children with cancer. So I'm under the mentorship of Dr. Michelle Fortier at the Center Stress and Health Lab, currently housed at Chalk Children's. So just an overview of the project. Basically what Pain Buddy is an ambulatory mobile health application that is supported by iOS and Android systems. From these systems, they're inputted into the patients and participants' personal handheld devices for easy and quick access. And any data they put, it captures real-time data, and it's sent over directly to our servers. What these participants do is fill out daily diaries twice a day, in the morning and in the evening, for a total of 60 days. The children basically report on symptom descriptions and frequencies, as you can see by the pictures below. So they're given with options of symptoms, basically like, do you feel any pain or discomfort, stomach aches, things of that sort, and they put them like in the yes or no boxes. And then from anything they picked in the yes, then they're asked how often, and then just any follow-up descriptions as well. And based on these, if a symptom alert is triggered based on the algorithm, if the child is experiencing significant amount of pain or symptoms, a healthcare provider would be notified, and the healthcare provider will then contact the patient and let them know exactly what is it that they could be used. Say like if they should try a CBT training, which is like belly breathing, body relaxation, or guided imagery, or if they should come in to like the emergency appointment clinic, or if they need to take some specific medication. The importance of this project is that it basically improves the overall quality of life. So in an outpatient setting, families and primary caregivers are faced with endless challenges and only have limited sources, especially for those families who are not primarily English-speaking families. They do not know about all the resources they have, and sometimes it may be a struggle to them to contact their primary health providers. And in an outpatient setting, this app kind of helps the child and the families control the child's pain and symptoms at home. And as well, it will decrease the prevalence and intensity of daily pain and symptom episodes. So if they know that they have these trainings that they can just easily access on their phone or on their iPad, they can practice daily and kind of improve their quality of life. As well, we know that there's like a large opioid epidemic going on. So we want to make sure that all the treatment that these kids are getting treated with, that they're necessary and appropriate for the pain they're feeling. So kind of optimizing that pain management and assessing it, and as well limiting the widespread misuse of it, just making sure that it's appropriate for them. The overall study progress, so active recruitment began last summer in 2019, and it's currently ongoing. So overall, there have been a total of 7 participants that have completed the total study. There are 10 in progress. 4 lost to follow-up, kind of just patients that we no longer contacted, or they moved away, or just no longer interested. So a total of 21. But now, since COVID-19 happened, kind of the current challenges that we have been experiencing is kind of having participants that are eligible and retaining them on the study, as well as them questioning our authenticity due to not being able to do in-person recruitment. So before, we would be allowed to go into hospital grounds and like the OPI clinic and cancer clinic and talk to these patients directly, so they would feel more comfortable and know that we were directly working with the hospital and we weren't just some random person like calling them. So that's kind of what we're struggling with now. And of course, we had to navigate away from that in person. So now we're doing like over the phone or via Zoom. And currently I do focus on more of doing remote screening and monitoring. Future work is that we could possibly implement Pain Buddy application in other healthcare settings. So further research to kind of understand and address the varying needs of other healthcare specialties, just because Pain Buddy itself right now, the program we have is specifically for outpatient settings, and the symptoms and kind of treatment that is associated with an outpatient care varies quite drastically from that of inpatient. And as well managing chronic pain in children, just because there has been evidence in prior research that untreated chronic pain can lead to both psychological and physiological disorders in later adulthood. So just trying to manage and better assess those pain and symptoms in children, as well as implementing non-pharmacological interventions that are both feasible and accessible to all our families. And as well, a last thank you to my mentor, Dr. Michelle Fortier, and all the staff at the Center of Stress and Health that have guided me throughout this whole journey. Thank you.
Thank you. Questions?
I had a quick question just in terms of trying to recruit people during a pandemic.
Yeah, of course.
So you talked about how there currently is issues of like trying to communicate to possible, or like recruiting during this time when it's like people don't know whether it's a legitimate study just from like a phone call or from a communication. Are there any organizations that you're able, like, are there ways to like partner up with people that are able to get you in contact with people that like that possible patients would know is a reputable source? Or is the main way to reach people just through direct contacting?
So the patients that we recruit, we get them directly from the patient list from the hospital itself. So it's not an organization that would have information of these patients as well. So what we do, I guess now that we're doing phone calls and everything, is that when we're calling a participant, if we're able to, prior sending them like information sheets on what the study is, or like a flyer that has like the hospital logo, or just that looks more official, so they're able to read over it and kind of look into it if they want to, and then we could address any more questions and like follow-up calls.
Okay, that makes sense. Thank you.
Any other questions? Judith, again, we're proud of you, and we thank Professor Fourier and Heidi and the team collaborators for all the work. So, Judith, what's your outlook about the future?
My what?
What's your outlook about the future? How did this experience impact you?
And impacted me, I think, like I want to continue at least doing something in clinical research, just because from all the various studies I do work on, I just don't work on this study. It makes me realize that kind of everything that can come from it, and how many problems there are in healthcare, and how underserved Latino families are as well. So just trying to improve healthcare overall.
That's very important, and we thank you, and the more power to you. Thank you so much. We're going to move on. I realize, Heidi, please, you want to say something?
Yes, thank you, Saeed. I just really wanted to thank Judith for working so hard with us this summer, being so flexible, and working with us to navigate the COVID situations and all the protocol changes that the hospital has implemented. So really, really appreciate you working with us, Judith. And I just really wanted to thank the SURF-IoT program, Saeed, GP, all the team, as well as Sergio, who's actually helping to manage our servers to ensure that the Pain Buddy program is working efficiently. So I really just wanted to thank the entire team.
Thank you so much. You're wonderful, and we thank you for what you have been doing. And God bless your child, and thank you for taking the time to join us.
Thank you.
We love that spirit. Very good. Again, we have a tight schedule, so with your permission, I'm gonna push through, and we might carve out some time out of lunch. So, Ananth, but I promise we will have a break after Yawan.
Can you see my screen?
Yes.
Okay. Hi, I'm Ananth. My project was on rapid prototyping and manufacturing. My mentor was Professor Jesse Jackson. So just for a quick overview, my project surrounds the viability of 3D printing as a method of design and prototyping, as well as manufacturing during a time of crisis. With the coronavirus outbreak, its potential really came to a head, and we saw a good example of it last week with Professor Jackson's presentation. If you recall, he managed to prototype around 5,000 face shields with his printers, and then manufacture another 10,000 with the best design he found. After this success, we really wanted to explore this potential of this technology and how we could improve upon it and streamline it so that we can better respond during a future crisis. So when we say rapid prototyping, what we really mean here is that we're looking at the ability to create multiple designs and test them immediately, as opposed to other methods, which would be far more expensive in terms of time and money. Often these models have to be adjusted during the prototyping process as well. However, with 3D printing, that wait time that's usually there with conventional methods is completely eliminated, where usually you'd have to like make a model, send it to a factory, have them deliver it, and then you can test it. Here you can just, I can print it on my computer and just have it immediately in the span of like 30 minutes. So that really eliminates a lot of the time. So really the goals here are to what extent is rapid prototyping plausible? How many prototypes can we make? How fast can we do it? And more importantly, how much faster is it than conventional methods? We also want to see the viability of 3D printing in mass production. Can we make printing faster? Can we make it more efficient? Could we make, compare it to something like a factory or a large-scale manufacturing facility? And our final goal is to see, can we make printing more efficient? Is there any issues that are preventing it from being a mass production item? Is there any way we can improve them, optimize them to make it more streamlined? So some of the obstacles we face from the beginning, there were problems with the printers themselves. During the printing of the shields in spring, many of the printers really reached the end of the line. We basically have two types of printers. One of them is called a printer bot. They're very mechanically strong, but they really lack any robust software or robust electronics. So they're really breaking down. Unfortunately, the company that manufactures them went out of business. So we were really out of parts, and they're very specific. So we had to turn to a third-party supplier, and we ended up having some problems with them later on. The other kind is called a Prusa, which is a higher quality printer. They didn't really have as many issues since they're more expensive but more higher quality. So they do need some maintenance, but overall they're more functional. So as I mentioned before, with the obstacles with the supplier, basically we bought them from a third party and we're having troubles with delivery. So unfortunately we don't have the parts we need to completely overhaul and upgrade the printers quite yet. In the meantime, we did manage to repair a couple of them. So we are now still working on the documentation process on the repair. So hopefully we don't have to relearn everything once we actually do get the parts. And if we personally aren't doing the repairs, it'll be easier for whoever is actually doing the repairs so they don't have to start from scratch. So for the main portion of the project, we were contacted by Professor Neil Young, who had the idea of creating handless door openers in order to minimize the contact with door handles, which are obviously very contaminated, and we want to avoid that now. So we started out designs from a company called Materialize. You can see one on the screen right there. Basically, the idea is we get two 3D printed parts and then basically clamp it around the handle, and basically we'd use our elbow or our arm to basically activate the handle instead of using our hand, which is obviously more contagious. So this is really where we got into the prototyping capability of the printers. Each of the models you see here is suited to a particular kind of door. So like cylindrical or doorknobs. They are relatively large prints, and usually on a large scale that would have taken a lot longer. But since we had the printers, we were able to print them out in a couple of days, as opposed to however long it would take for them to deliver it to us in a normal way. So we did run into some issues with this idea. One of them is that the company was situated, I think, in Norway, and they have a very different standard door sizes as opposed to American ones. So usually this wouldn't be an issue, but later on we learned that we had a meeting with the EH&S and the fire marshals, and they basically told us that basically they wouldn't allow any kind of modification to doors, because there's heavy rules and regulations, especially in California, that say you cannot modify the door in any kind of way, because that creates a safety hazard and that people might not be able to use the door. So they basically completely rejected the idea and said no, basically. So we kind of had to find a way to work around that. So our new solution are door hooks, which is slightly different. Instead of actually attaching a print to the door, we would create personalized door hooks. The one above you is a good example. We found this model online, and there were a couple more similar to it. We were able to print out and test some of these parts, and for the most part, they were adequate, but not perfect. A couple of clinics and nursing homes expressed interest, So we were able to print out about 100 of these and give them for use. But we did want to see if we can make it better and more ergonomic and overall stronger. So some issues we found with the basic hook, it was slightly weak, especially with like extremely heavy doors, and they are susceptible to high torsion. The one you see on the screen is an extreme example. That was me trying my best to just to destroy it. So that wouldn't really happen with an average one, but it is a concern, especially if like a door is locked and you thought it was open and you really just try to like swing it open, you might get some shattering. So what we wanted to do was we needed to make it more strong. We needed to find a way to get around the friction aspect, because between the contact between the plastic and the metal, there was a lot of slipping. So that really makes it uncomfortable to use. And while it's not really a big issue, these minor inconveniences over time would make it a lot more annoying to use. So we found that like we were actually kind of avoiding using it just because it was such an inconvenience. So this was our first model. As you can see, we would kind of hold it like a key. It's kind of hard to describe over a PowerPoint, but I'll try my best. This model basically was stronger than before because of the arch shape. It's kind of like, if you can imagine like a dam has a similar curvature and that gives it strength. So it was a lot stronger than it was with the original design, but it is still breakable and it is kind of hard to hold. So keeping that in mind, we moved on to our next model, which is this one. This one, we decided to change the way we would hold it so that we could wrap our finger around the hook, so that instead of the actual part taking the brunt of the weight, it's basically your finger. It was, strength is no longer an issue. It's extremely strong, and like even if I was like trying to break it, it would be basically impossible. Cons are that it does slip. It still has that friction problem, and it slips from your hand pretty easily. So with the fourth design, I tried to elevate the thumb part. You can see here. It wasn't a very good idea, but it did lead to a better design later on. This one was the fifth idea. Basically, you'd use your middle finger as the support, like the pointer finger was before, and you'd use your ring finger and your index finger on these two ledges here as to create a better support. It was a good grip and it was very strong, but it was a little awkward and it was really hard to print. As you can see here on the bottom picture, it doesn't print out very well, and in terms of mass production, that's not ideal. Which leads us to our third our final model design. This one, we eliminated one of the final ledges, and we basically left the one for the middle finger and just had your thumb lie on the other side and your pointer finger go over the arch. This was much stronger, even with like the heaviest doors. I couldn't break it even if I physically tried to. Very ergonomic. The technique is a little confusing, so we are working on that. And we basically just tried to like evolve it to this model, and then to the final model you see on the bottom right, which I swear it was a coincidence, but it kind of looks like an anteater, but I think that's fitting. Which leads us to now. Basically, we finalized the design, and what we're working on now is the friction component, which is, we can't really improve it with 3D printing alone, just because the material is always going to be slippery. So our new idea is to attach a thin layer of rubber on the arch itself so that it can really clamp onto the handle, and it's working really well. We're considering injection molding as a way of faster manufacturing if there is a demand for them in the future. So in conclusion, in terms of rapid prototyping, we found that 3D printing was extremely useful. Really the only limit we found was that how fast can I design it? Because I can manufacture it in 30 minutes, but the design process takes longer. So really the only limit is how quickly can you model things and how quickly can you adapt. In terms of mass production, there was an upper limit. It's good for small batches, so in like the low hundreds, it would be very good. But when we approach the thousands, it doesn't even compare to a manufacturing facility or a factory. So it's good for small things and it's much more cheap for small batches. But if you're going mass production, if you're giving them to everyone in the college, for example, you really want to go to a full-blown facility. And we found it is very good for crisis response. these designs will be able to done in a matter of weeks, even shorter if we were really pushing it. So looking forward, short term, we just need to finalize the hooks with some minor changes, and we're probably gonna start producing those. If they're effective, we'll probably start mass producing them with like injection molding, as I mentioned before. In the meantime, some of the teams are expressing interest in face shields because they're doing some field research in LA, and they wanted some more face shields, so we're probably gonna do those. In long term, we really wanna upgrade the printer farm, and I mentioned a synchronized printer farm last time. That one is seeming like a bit more of a long-term thing, but we are hopeful, and hopefully we'll have it by maybe next year. And that is it for me. Is there any questions?
I have a few questions.
All right.
So,
You can stop sharing it now.
yeah. So I'm not sure if I caught this, but do you imagine people are carrying these hooks like just in their pockets, or is it just staying on the doors themselves?
They'd basically be like on your keychain, and you can just pull it out and use it on the door.
Got it. And another question. So the prototypes you guys are making, they're just ABS or PLA or something like that?
Oh, PLA. Yeah.
PLA, okay. And I think you said your long-term goal is to use injection molding, so I'm assuming you use a strong material at the end of the day, right?
Yeah.
Okay. And the increase of the strength of your new models, is it due to the newer design? Is also, so it's the same material from design to design, right? So the strength is coming from the, I guess, the geometry of the design and—
Yeah, basically.
Okay, and perhaps the density of the
density, I think we kept the same. I think I upped it up maybe like 5%, but it's not, I don't think it's like very significant.
Got it. Okay, cool. Thank you.
You just want to follow up on this design aspect. Which software platform do you use, and were you able to manipulate the parameters to test it for stress and to bring it to failure? Sometimes
Yeah,
the computer will allow you to come up with better design.
I use SolidWorks, and they have like a simulation platform as well. So once you make the model, you can test different stresses on it. I didn't rely too heavily on that because that does take a lot more time, but I did a couple of tests, but nothing too extensive.
Very good. Thank you so much, and this is exciting. Regine?
Let me start sharing my screen.
Wonderful. We're happy to have you.
Yeah. Hi. Yeah, so my name is Regine. This summer with SURF-IoT, I would focus on a project on exploring multimodal voice interface design in Alexa Games for Children. Now, let me go ahead and start going over what I'm going to introduce today. A couple of different topics to cover, but let me start off with introducing some context about my project. First off, by 2022, 55% of American households will have a voice assistant. Now, this is a really pivotal time for the IoT space because this is a serviceable, available market for voice assistants. There is a demand for parental education activities now, and then developers such as Google, Apple, and other developers and manufacturers want to increase creating these platforms for children. There is a huge design opportunity as well. Assistive and educational technology for speech therapy in that space. It's about $100 an hour for private speech therapy. And in the United States, we all know that like health insurance is pretty volatile in the sense that this can add up for the average family just for one child. If you're doing this once a week or multiple times a month, it does add up. So this is a convenient option for families. There are gaps in research. There's not a lot of design guidelines for games, and there's also limited empirical studies with children using VAs. So this is a very new field. Now, my project aim is to investigate the design practices for children, for child-computer interaction in the context of games. Now, why should society care about this? My impact of my work is that it offers agency for children to speak and play using VAs, and it generates design and development guidelines for creating child-friendly VAs. There is a lot to explore in this field, so this pretty much is a pioneer in the IoT space for children. My research goals is to improve children's interactions with VA Alexa through game prototyping and playtesting, especially with kids from ages 3 to 6. I also wanted to improve multimodal design and conversational design with handling errors, revising conversational prompts, adding game levels, and integrating visual design. So there are a lot of factors that go into Alexa development. It's not just designing an app, but you are designing a lot of different factors, auditorial, visual, and interactional modes within developing with Amazon Alexa. Now I'm going to dive deeper into my development progress. There are different factors that went into these last 10 weeks. So here are some milestones from the last 10 weeks. From week 1 to week 4, I developed the help, repeat, and error handlers so players can ask for assistance in the game. These are pretty much adding different handlers with JavaScript to enhance the game functionality. Now, weeks 5 to 6, I enhanced encouraging messages and positive responses with SSML, which is speech synthesis markup language. These make Alexa sound more human. It gives her personality. Because as you can see, I know a lot of you guys did mention that you do have an Alexa or a Google Home in your home, and she sounds like a robot. Like, this adds more personality to her. It also I also improved game level design to consider players' endurance. This is because not a lot of kids can keep up with the game. Week 7 to week 8, I did a couple of things. First, I did some opportunity assessments with third-party APIs. These were ways for us to figure out if there's another better way to implement like the dialogue features, or using Python for these APIs, what can synergize with our current existing platform. I also redesigned SSML features from QA feedback. Since I'm not an expert in QA or speech pathology, it was really important to get that from my other teammates, what their feedback was. From week 9 to 10, I implemented countdown audio to enhance response time experience. I also increased response time, which didn't exist in the game. I will go deeper into the error handler first about in my development. Now, children make errors due to their developing speech and language skills, which is pretty natural. So before, there was no designated error response. There wasn't anything that was triggering it. There was no fallback intent. And instead, Alexa provided the hint to the next user, even though the user didn't know what was going on or was probably lost. So what I changed was I adjusted the fallback sensitivity from low to medium. This is a feature within Alexa, and I adjusted the fallback sensitivity, which is basically a feature within most intelligent personal assistants. It captures utterances differently from a low confidence to a medium confidence. I added common error responses such as what, how, and I don't know. And these are common utterances from children that we had tested in the past. Now, when the end user would say, with the changes, now when the end user would say an error response, Alexa says, if you don't know, that's okay. You can ask for help if you're not sure. This then triggers the help handler and proceeds to help with additional hints. This has changed the game architecture. However, it allows a feedback when there is a utterance that provides an error for the child. For my game level design, prior use testing suggested that simple to complex progression with reduced numbers of questions per level. Before, the end user would need to complete the entire question set without the break. We have two game stages, which was the animal stage and the action stage. This is all about game level design in this between those two. For changes that I made, I implemented game level design to transition game stages after 5 questions. Basically, after every 5 questions, Alexa will say, that was fun, would you like to keep playing with me? If yes, the next set of questions will be asked, and if no, Alexa will thank end user for helping. Very child-friendly. It doesn't pressure the child anymore instead and forcing them into playing the game. I also increased the response time. This is actually specifically for developing special needs children that actually will need the increased response time for comprehension with Alexa. So before, there was no indication of response time. It was very open-ended, and this was something very present with Alexa games that you find on the market right now. There is no indication of what's going on in terms of like how soon the child needs to respond. Users did not know when to answer as well. Now the changes I had added was I added countdown music to indicate a lot of time, which is up to 30 seconds. Now if the user, if the question is given, countdown music plays while the end user continues to think about potential answer. This engages them, allows them to think about and contemplate their response during the game. So here is some markups, and also not markups, but also screenshots of the under the hood. The Alexa Developer Console is pretty interesting. It's a different IDE. It's different from the IDEs I've used before. You can actually just type everything out and get the responses and how it'll come out. This is really interesting because usually you'll have to talk to an Alexa, but this makes it a lot easier. We also did a Kanban style for product management. We had a lot of development in the backlog, and also this is how we kind of kept in progress. This is also the icon in our game, which we'll be using for when you publish into the Alexa skills store. So now let me talk about my challenges and lessons that I've learned. First off, there was a lot of technical limitations at Amazon Alexa platform. There's a lot of debugging issues. The console was sometimes kind of finicky. There was also friction between Amazon engineers and developers. The technical limitations were always something that it's outside of the normal software development process. So a lot of times I would have to log on to office hours that Amazon provides, where Amazon engineers help you figure out what to do and how to enhance something. They're also very limited, so that friction was also present. You couldn't just ask Amazon engineer, you'd have to actually ask through their help us or the contact us form. Another one was limited options for documentation and online support. So a lot of developers, we rely on Stack Overflow, Reddit, and other developer communities. Specifically, the online support community did not have a lot of helpful advice because, once again, this is a very new platform. Also, with third-party integrations, it was really difficult to synergize with the existing Alexa platforms. For example, the countdown music that was not owned by Amazon often has errors or bugs. This is like something like similar how YouTube has limitations with like their copyright, or something that's going on where they just don't allow third parties. There is a lot of issues with that we are overcoming this fall. I learned that Amazon Alexa is still a relatively new platform, and that direct Amazon support was more helpful than community support. That was like a really big thing that affected how my development process would go through the summer. But now that I'm learning and I'm getting used to the platform, this is something that I will directly do from now on. Their help support was pretty helpful. They actually get to look under the hood and like point out things that you should add. So it's really awesome that Amazon is involved through this process. Here are my future plans. I'm going to continue multimodal interaction design in fall quarter. We're gonna add solutions such as Amazon Poly. We also will analyze quality assurance tests to the Amazon Alexa skill store in this fall. This is a really great opportunity because we'll gain new function in development insights from the Amazon Alexa Consumer Network. Also, Alexa is one of the more, it's more present in most households compared to other competitors such as Google and Apple, which they do have their own home devices, but Alexa has a bigger network. We also want to expand remote testing with adults and children using the Zoom platform during COVID-19. Also, if you would like to consider playing with our skill, feel free to also email me as well for more info. And I also wanted special thanks to Professor Katie Sound, Tech and Boss, and Yadu, and the SURF-IoT committee, just for everything they've done this summer. And I will take questions now. That was my end of my presentation.
Outstanding presentation. Thank you, Regine. We appreciate it. Questions, please.
I had a quick question just in regards to like that countdown music, just because it stood out. So I'm just imagining that if I was a kid, like if it was like kind of like Jeopardy music going on in the background, then it might be a little bit stressful in terms of like having the feeling of an expectation of a response immediately. So I'm just interested in whether there's like, if there was thought process into whether like how to do, what music would be effective to both like indicate time, but also not put pressure that could like lead to more stress on the user.
Yeah, it's actually funny that you mentioned that because the Amazon Music countdown music that's owned by Amazon sounds like Jeopardy music. So we were thinking like, oh, let's like try new third-party music. That was an issue because Amazon doesn't allow it. So there's some design constraints with that. But I do agree. We did put a lot of thought process, like is 30 seconds too long? Is 10 seconds too long? Is 5 seconds enough? So that is still something that we are working on, those design constraints. But I had the same idea as you as well. It's like, is this like too much pressure? So we are learning. We are going to be able to do some more testing and see if it makes these kids feel pressured or if it's something that's helpful for them.
Yeah, thank you.
Mm-hmm.
So Regine, how did this experience impact you?
Yeah, so I actually found out this lab like 3 years ago when I was at MIT for like a hackathon, and I was talking to the Education Arcade director about interactive play with children because I've always thought it was really interesting. And he said, oh, at UCI, they have this lab. And I was like, really? I didn't know that. I was at another university before UCI. So the fact that I landed into this IoT fellowship was like a miracle because it's like, I heard about this just by word of mouth. And I really thought about, I really want to work and do research in this field. And it's really exciting. There is a lot of work that needs to be done. I also, right now I'm currently balancing different opportunities in my future with my career. And I think right now I'm going to pursue a career option because I already have like a couple job offers that I have for next year. But I do eventually want to continue doing this research because I've always really was interested in technology and for good. And this is something that will advance speech pathology, Alexa, the Alexa platform. There's a lot of different factors in here that will expand the field of IoT. So with that in mind, I definitely think this is something that's going to be a part of my future. And I am really excited to be part of the research continuing this fall, just because I just started this in June. So this is relatively new to me. So I'm excited to be a part of this next quarter.
Again, we're proud of you and we wish you continued success. And the same for all the rest of the fellows. It's these opportunities, it's these experiences that's hopefully gonna bring clarity to how you wanna continue this journey. And I'm talking about the life journey. So thank you again, Regine. with your permission, unless there are any objections, can we invite Yawen to do her presentation, or would you like to break? Is that okay if we do her presentation? Any objections? Very good. Yawen, it's yours. The floor is yours.
Okay, let me share my screen. Can you see my screen?
Great, thank you.
Hi, my name is Sawan. The topic the topic of my research is understanding patient questions about their medical data in online health communities. And here are some bullet points that I'll be talking about today. So while patients now have greater access to their medical data, research suggests that patients often have difficulties understanding the information contained in the data. So in order to actually use the available data for personalized decision-making, patients often have to search for more knowledge in order to understand the data. And there are increasing number of health forums which provide users with a platform to ask their health-related questions, so that others help to interpret the data and make informed decisions. And this content is usually posted publicly, which provides an opportunity for researchers to understand the nature of patients' questions about their clinical data and about their own health. And that is also the goal of our research. And the reasons we're doing this is that providing more personalized support for patients at the point of viewing their laboratory test result could offer a number of benefits, like increase patient engagement in their healthcare, or improve patient-provider communication, and to make a better health outcomes. And the first steps of our research is data collection and data analysis. We collected question posts that contain laboratory test results from a popular online health community, and we took an initial random sample of 1,000 of these posts for analysis. And to analyze our data, we use an inductive quantitative analysis approach. Here's a screenshot of the software we use. And then we look at coding metrics to identify patterns in our data. For the first matrix, the rows are post-appointment and pre-consultation. And for this matrix, the rows are general and specific. General is one of the question patterns. These questions usually ask for all possible risk, diagnosis, or treatments. And specific is another question pattern. These questions ask about a specific condition, behavior, or lab value. And from this matrix, we can see that the many posts are about our post-appointment, and they are posting about the cost diagnosis. And from this matrix, we can see that questions that are specific are posting the cause and diagnosis as well. And in our sample, it is typically the patients bring their own laboratory test result to the online health community, but sometimes it is a family member posting on behalf of them. And the online community is primarily made up of pair patients. However, there's sometimes some healthcare provider that may respond. And there are some types of questions I'm going to talk about. The first one is the straightforward. For example, in this post, this person is asking the community to interpret their HPV test result. And in this one, another type of question is posing about a complex story. Here's an example. And this is also the advantage of online health forums over Google. So the online health forums allow you to include the context and ask full questions rather than just providing the keywords, and they're interactive. There are mainly 3 types of questions under the cause and diagnosis topic. I will talk more about them in later slides soon. So in the first theme, the patient posting on the OHC tends to ask more open questions meant to gather ideas about the cause of their abdominal results or symptoms. So in this example, this person has multiple specialists and has not been able to get any satisfactory answers from them about what he has. So he has broadly asked the community, can anyone help me? In the second question theme, the individual posting already has an idea of the potential cause and is checking or verifying their ideas with online community. In this example, the patient provides additional test results to illustrate why they do not feel like either of the research-driven ideas are actually the cause in their case. And finally, they seem to want the community's help in assessing their hypothesis and in gathering information as they are waiting for their appointment with a specialist. And finally, some patients post in order to gather information about additional tests that they could get in order to determine the cause of their abdominal laboratory test result or symptoms. For example, in this post, the patient is concerned that her TSH has continued to increase over the course of a year, and her symptoms have not been alleviated despite increasingly higher dosage of medication, where she's trying to gather suggestions about her next step should be. Usually, these treatments and management that need to be prescribed or performed, as well as monitored by a doctor. But sometimes patients ask the community for recommendations for self-management options, such as diet changes or supplement. So sometimes patients posting about the management and treatment topic online. And then now I'll talk about the reasons that people post laboratory test result online. The first one is the gap between receiving results and healthcare visits. So patients bring their laboratory test result online in order to fill the gaps in information and communication, and sometimes to seek help in making decisions. For many patients, this is just one part of their support-seeking efforts, which may also include reaching out to the healthcare professionals, families, or friends, as well as using other online resources. In this example, the patient clearly found her results upsetting and has tried to contact some professionals for more information for help understanding her results with no success. And the second reason that patients come to the OHC is to prepare for an upcoming healthcare visit. As shown in this example, some patients feel like this preparation is critical to arm themselves with information so that they can advocate for themselves and get what they need out of the visit. And in some cases, the provider may fail to provide important information altogether. Like in the first example, the doctor seemingly only communicated that the levels should decrease over time, failing to mention that the patient increased risk for those serious conditions. And in other cases, the provider may fail to answer the patient's questions, or the patients may not understand their provider's answers. Like in this second example, by omitting crucial information, the healthcare provider missed an opportunity to address the patient's subsequent information needs, results in the patient seeking this information elsewhere. And also, this may because of the perceived knowledge in healthcare provider. Like in this example, the patient does not seem to fully trust their doctor's treatment guidance because the provider doesn't have specialized training specific to their condition. So the patient then ask the community whether they need an additional test, and based on their test result, they do have whether their medication should be adjusted. And it may also because of insufficient support for decision making. So patients often need to make decisions based on their laboratory test result, often in conjunction with other information. And they bring their test result to the OHC because they are not receiving sufficient support from their healthcare providers. And in our sample, the decisions included determine if medical follow-up is even needed and how urgently, and making testing or treatment decisions. So here's the discussion. So after the research, I'm thinking what might be missing in offline care, maybe because of the trust. Maybe there's a factor that is the trust in healthcare provider, or temporal gap in medical treatment, like the waiting time, or patient's own knowledge and expertise. And thank you.
Great job, Joanne. I invite everyone to ask questions. If you ask a question, you will get a free virtual lunch. Darwin, what do you think?
I have some, I don't really have a question, but I was just kind of thinking about it, how, you know, a lot of people before they even go to the doctor, they'll just Google their symptoms and then freak themselves out. So I think this is valuable where you're just improving the work for healthcare offline, so that, especially in times like now where, you know, not everything is credible online, and you know, there's higher levels of anxiety. I think it's a good thing to raise the credibility of offline care, for sure. That's just something I was thinking about.
That's a beautiful point. John, you look like you want to ask something or comment.
I think it was a good presentation.
All right. So, John, what does the future look like?
So we are presenting the we are working on a paper now, and we may present these ideas into that paper.
Wonderful, wonderful. Again, congratulations to our wonderful presenters, and I know we have also more wonderful, well, we have additional presentations that are also going to be wonderful and exciting this afternoon. And I do apologize in advance, but we're going to make the lunch only a half an hour. And Sonia, you can stop recording now. And what our session of the SURF-IoT 2020 Symposium. And we had wonderful presentations this morning, and then we're going to have more this afternoon. I think everybody can attest to the fact that we're just so proud of the progress that fellows have made, the impact it's had on them, and really of most importance is that I want to express our gratitude again to the faculty mentors. This whole enterprise would not have happened without their efforts and their commitment to mentoring students and supporting their journeys. So I start by, again, thanking the mentors for everything that they have done. In the interest of time, and again, we have a very tight schedule, so we might squeeze in like a 5-minute break in the middle because it's the afternoon. I'm gonna, and then Sonia and I will moderate. But I'm gonna invite Yilei to share with us her presentation. His presentation.
Oh, hi.
I do apologize about mispronouncing names.
Yeah, it's very good. So, hi everyone. My name is Yilei Wu, also goes by Sean. In the project name is called Automate 3D Cardiac MRI Segmentation. And for this project, I'm working closely with the graduate student Saeed from the X department, and the project being advised by Professor Hamid Jaffarkhani from the X department and Professor Arash Kalever from the BME department. And before I talk about any thing about the project, I retrieved 5 MRI images from one single subject. And so these 5 images are retrieved from one single heart at the one single phrase. And the reason why they are different is they are cut from the different position on the z-axis. That you may imagine that it's a heart, and they're doing the MRI segment. They're doing the MRI cut on the different position on the y-axis. That's the reason why it's showing different. And the red box here, a square here, is the right ventricle that we're trying to segment. And so yeah, and so the goal of this project is just for us to make the algorithm itself can segment the right ventricle or left ventricle without any manual input, and so that the machine learning algorithm itself can determine what's the area of the right or left ventricle. And this project is also easily adapt to other other uses if we would like to detect the lesion or the tumor on the cardiac MRI images. And I'd like to talk about why the project is important, since the previous sample MRI image was retrieved from a healthy heart. So we may see the boundary of the heart chamber is very clear, and also the shape is very discernible. But the real MRI image that we use in our training is heart with the congenital heart diseases. Those heart chambers are very undistinguishable, and the boundaries sometimes blur. So it's also very challenging for the physician to detect the boundaries. And so the segmentation autonomy is very important qualification. It's a very diagnostic signals for the physicians, because after the proper segmentation, we can easily calculate the chamber volume or and the ejection fraction, and that's provide a very important information for physicians to do the further diagnosis. And usually in the past, that the segmentation is done manually by the physicians. Thus, and also it's very time-consuming job. So if our algorithm can automate the process for doing segmentation, it will save the expense to a great extent. And one major difficulty prevent us from conducting the traditional machine learning approach is the lack of the MRI data set. So each different hospital has its own private data set, and it's pretty much very impossible for us to, if we would like to combine the data set, because the different medical sector, they use the very different standard. And even if we can combine 2 of them, we cannot combine 20 of them. And that's the amount of the data set images that we usually need if we need to conduct traditional machine learning images. And it was required by the CNN image recognition method. And I would like to discuss the approach that we used to solve this problem. So for us, for resolving that problem, we need to augment our MRI image data set, and the approach that we use here is we incorporate the synthetical image generated by the generative adversarial neural network. And so the use of the generative, the name of the network is generative adversarial neural network. It's very new neural network. I think it's only being proposed in 2014 by Ian Goodflow, who's a very famous researcher in the machine learning area. And so if a GAN being properly trained, it can generate very high quality image under certain categories. And we may see the right bottom image that these are, none of these enemy characters are come from the existed literature. They are not coming from the animation or any comic. They are purely generated by the GAN, with by the GAN being properly trained on another enemy character enemy data set. And that's a comparatively, the reason why I put this image here is to demonstrate the performance of the GAN. And yeah, we may see that this author that they categorize the character into 4 categories, A, B, C, D. And in our case, that we only have 2 categories, which is left ventricle and right ventricle. And we use the fairly small number of data set to train the GAN, and so that and it's properly trained. So the GAN itself can generate the high quality synthetical MRI images. And the left images is the structure of the GAN network that we used. The blue sector is the generator, and the right sector is the discriminator. And that's why this neural network was being named called the adversarial neural network, because these 2 networks, they combat with each other to achieve the eventual convergence. Yeah, so in this case that we augment our data set to a lot, and so that we can conduct the convolutional neural network image recognition for the further uses. And finally, I would like to discuss my work during this summer and what I'm going to do in the future. I've been working on the project since last year. So in the first 3 weeks, I helped Sai with to address all the revision comments that we received just before this summer. And most of my jobs include like generate the statistical report and to adjust some analysis accordingly with the revision comments. And after that, I majorly working on the development of 3D generative neural network. And I spent a lot of time in tuning and testing the neural nets. Unfortunately, at this point, I haven't achieved the convergence for the 3D version of this network. So there's not image that I can present today. And recently, I've just been assigned to help Professor Hadaver's team on web application plug-in things that I need to build for the web, help them build the web application for the demonstration purpose. Also is related to this project. And in the future, I hope that I can tune well the 3D GAN and to get better performance of the 3D project. And yeah, that is the things I'm going to do in the future. And that's it for my.
Okay, Yilei, that was a great presentation. Thank you. It's everyone give Yilei a hand.
and feel free to unshare your screen. So any feedback for this amazing presentation and work that he is involved in?
I have a quick question just about like the generating the different image or the different variations of the segmentation data. So is there any way to like set up the constraints for the generation to make sure that whatever image is generated from it is still conforming to like proper human anatomy, or like making sure that it's like way to check the data to make sure that it's still valuable in terms of being able to train that neural network that can do the segmentation?
I'm sorry, what's your question?
It was just a question of like when creating the different like variations on the specific heart image, for example, like to create the generative different images. Is there like a specific way to be able to make sure that, like, to quality check those generations to make sure that they're still viable in the usage of the system?
That's a very, yes, that's very important. Yeah, so like the traditional method in the GAN, that they have two matrices. One is we can use it's called the inception score. Like basically we feed the image into a neural net called the inception net, and it will trying to we feed the output of synthetic image into a net called inception net, and the inception net will basically like to discern like how the quality of the edge of that image, and it will give a score of how basically what's the authenticity of the image. And another is called the FID score. It will compare the synthetic data set with the original data set to see what's like the how to evaluate the performance of the synthetic image data set. And yeah, that's also another. And I think the FID is more useful because it's used the original data set. And the inception would be some kind of, yeah, it's very old compared with the FID. So yeah, but there's a lot of ways, and there's a new method coming up recently to evaluate what's the quality of the synthetic image.
Okay, thank you.
Great question, Aviv. Anybody else, any comments, questions, any comparisons, or anything that might relate to the project that you are working on? No?
I guess one question I have is, at the last slide, you said you wanted the 3D model to have a better accuracy than the 2D model. Is that correct? So I was just, I'm sorry, did you hear me? I'm sorry.
Yeah.
Okay. So I was wondering, what's the accuracy rate of the 2D model, and like how far away is the accuracy of the 3D model from overtaking the 2D model in terms of accuracy?
Okay, yeah. So we evaluate that the output of the project is a mask that the algorithm itself think that this is the ventricle. Is the ventricle area, and the matrices that we trying to evaluate the accuracy that we have the dice ventricle is like how many percentage of the overlap of the mask with the ground truth was drawn by the physician, and we have a bunch of other matrices that we can evaluate. For the dice, it's like 84 percentage. So it basically means that we have like 84 overlap in the area with our original, and we expect to get better score if we can successfully train the 3D project. And the volume is also we have a kind of very little error in terms of the volume calculation for the chamber volume. Yes.
All right, awesome. Thank you.
Great. Well, thank you, Yilei. We'll move on to Angelou. Are you ready for your presentation?
Yes, I
Go
am.
ahead and share your screen, please. Thank you.
Nope. Okay. Sorry, I'm just playing with the settings. Okay. So good afternoon, everyone. My name is Angelou Lao. I'm a biomedical engineering major. And this summer, I worked on the detection of the SARS-CoV-2 virus, pictured here, in saliva under the mentorship of Professor Kine and her graduate student, Julia Zakashansky. So I'll just go ahead and actually start with my own experience with COVID-19 PCR, or polymerase chain reaction testing. So I personally had to wait 3 months just to get free COVID testing from the city of Irvine because I never had symptoms, but I still wanted to test myself in case I was asymptomatic. So when I finally got tested, I actually had to collect my sample via nasal swab myself, just like this guy, to eliminate the risk of transmission to healthcare workers. This was very painful, and it was very difficult to do myself because it was very painful. So after that, I also had to wait 2 days to get my results, which felt like such a long time to be uncertain about something so important. So from this experience, I was able to see the disadvantages of COVID-19 testing firsthand, which made me feel like I had a stake in this project, and it should make all of you feel like you have a stake in my project as well, because this is the current reality of COVID testing for nearly everyone. So our project is to address all the disadvantages to current testing that I just described. We asked ourselves, how do we make testing more accessible? As shown by this diagram that details the process of PCR testing requires a lot of equipment, effort, time, and money. We also asked ourselves, how do we make the test less invasive? And finally, how do we prevent the risk of transmission to healthcare workers who have to collect and process the samples? So a logical conclusion to come to would be to create an affordable COVID-19 test that can be self-administered at home with no additional equipment required. A test that uses non-invasive sample collection, such as saliva collection, and a test that can produce results quickly. So there is actually existing technology that is pretty close to what I just described, and it's called the immunoassay. The immunoassay, as shown here, tests for antibodies. This structure circled in green. Antibodies are produced by our immune systems to deactivate viruses. Unfortunately, an active infection of COVID-19 is not accurately represented by the presence of antibodies. Antibodies are produced about 3 days after initial infection. So between 0 and 3 days of a patient's initial infection, an immunoassay couldn't accurately detect COVID-19. Also, antibodies stay in the body after infection. So an immunoassay could inaccurately detect COVID-19 when a patient was infected but is not actually contagious anymore. Our project, an aptamer-based assay, aims to address the disadvantages of both PCR testing and the immunoassay. Our project aims to possess all the beneficial characteristics of the immunoassay. We want it to be accessible, we want it to reduce the risks of transmission to healthcare workers, and we want it to be non-invasive saliva sample collection. And finally, we want to get faster results in as soon as about 30 minutes. The difference is that our test will detect the spike glycoprotein, or S protein, as I'll be referring to it from now on. It's a component of the coronavirus, and by detecting this, it ensures the accurate detection of an active infection, unlike antibodies. So we envision our test to be on this portable system pictured here that Darwin has been working on since our mid-program check-in, which he will discuss later. I will be discussing my progress on the electrode detection platform of our device. So on our aptamer-based assay, the S protein, represented by these red structures on the surface here in this green circle, will be detected by methylene blue aptamers, these colorful sequences. Aptamers are short single-stranded DNA that selectively bind to a target. In our case, the target is the S protein. This third picture here is a blown-up diagram of an aptamer and a molecule called methylene blue that the aptamer is tagged with. You'll see that in both pictures, these aptamers are bound to a gold surface here and here. This is because when we apply voltage or an electrical force that drives the flow of electrons, methylene blue can transfer electrons with the gold surface as shown by this gray arrow right here. This transfer of electrons is measured by current as shown by this orange signal peak. So when this S protein binds to our aptamer, the aptamer will undergo a conformational change in which methylene blue moves closer to the gold surface here, changing the rate at which electrons are transferred. Its subsequent change in current, as shown by the second higher orange signal peak, can also be measured. So thus, our assay will detect the S protein by measuring the change in the rate of electron transfer between the methylene blue and the gold surface, or this change here in orange signal peak height. When S protein is detected, current will increase and the peak height will also increase. So for this presentation, unlike my mid-program check-in, I actually want to describe our experimental setup so you can all have a better understanding of how we collect data. So this device here that's connected to the phone is called a potentiostat, and it's what we use to measure current or signal produced by our electrode here with the aptamers that I just talked about, while the electrode is in a solution of S protein. So to collect the frequency map data, we need to keep the concentration of S protein constant while we vary the frequency that the potentiostat measures at. So in order to optimize the increase in signal peak height or signal gain, we determine the most optimal frequency to measure signal gain at. When the S protein is present and binds to our aptamers, electron transfer takes place at specific frequencies. So if we measure the signal at the frequencies that are closest to those of the electron transfer rates, we could maximize signal gain for the detection of S protein, which subsequently increases the sensitivity of our device. So as shown here, we determined that measuring the signal at 25, 75, and 100 Hertz produces the highest signal change from this baseline right here of 0% change. So for our concentration curve, we kept the frequency constant at 25, 50, and 75 Hertz. And we characterized the signal measured at varying concentrations of S protein. So earlier we claimed that when the S protein binds to our aptamers, signal increases. In order to actually verify this, we proved that at 75 Hertz, as a concentration of S protein increases, signal change also increases because the more aptamers are binding to the S protein. Okay, I am running out of time, so I'm gonna go ahead and speed it up a little. If I can get this to work. Okay. So for our selectivity tests, we continue to keep frequency constant at 75%, or 75 Hertz, excuse me. But then in addition to measuring the signal in solution with S protein, we also measure the signal in solution with human saliva amylase, which is another component in saliva. I'll refer to it as HSA from now on. So we validated that other components normally found in saliva, such as HSA, did not produce a significant signal change compared to that of the S protein. As shown, the change in signal peak height for the detection of S protein was significantly higher than that of HSA, which proves that when our device produces signal, it is in fact detecting the S protein and not just any other component of saliva. So in the future, we plan to prove that our test can differentiate between human samples with and without sorry, I can't really see my slides. Okay, with and without S protein. So previously we've just been using a solution with S protein, but testing human samples becomes more complex as there are other components of the human sample present. So we plan to validate this by showing that our device will produce a significantly lower change in signal for human samples without S protein versus human samples with the S protein. After this, Darwin will discuss his progress on the miniaturized electrochemical cell fabrication, the hardware component of this project, and the projected realization of our final product. But before he does that, I would like to thank the Cal IT2 team, the Europe team, Dr. Kine, and Julia Zakashansky once again. And I want to thank you all for listening to my presentation and supporting me throughout this program.
It's good stuff. Good stuff.
Very good. Good job, Angelou. Thank you. And I like the way you are dovetailing your presentations with Darwin. It makes it continually interesting. So thank you very much. So any feedback from our SURF-IoT team? Jason Lewell. I haven't seen you yet. Why don't you turn on your video? Oh, there you go. Can you hear us?
Yeah, sorry,
There
I
we go.
was playing with the mute button.
Yeah.
Yeah, I thought it was pretty interesting. Matter of fact, I'm taking the nozzle swab thing on Friday, since UCI is asking all the students to do that. So I thought if we have something very portable and feasible on the phone, then it's probably a good idea to, you know, kind of alleviate the pressure for all of the medical workers, and also like, you know, there's a lot of stress on the patients that are on everyone that's getting tested, because I am afraid of getting the virus when I'm there testing myself. So yeah, I think that's very good stuff.
Thanks. Yeah, and I just want to add a disclaimer. I don't want to discourage anyone from getting themselves tested because it's painful. I actually heard they made the test like less painful and less invasive so that it only touches like the outside part of your nose. But yeah.
Perfect. That's very reassuring.
Jonathan, do you have any questions or comments to Angelou's presentation and the saliva testing for COVID? Maybe he can't hear us. Okay, anyone else? Ananth, do you have any comments?
I didn't really have any questions, but I thought it was a great presentation. It's really to see, you know, this is something like so prevalent. It's nice to see like work being done, and, you know, that like I heard that was painful. One of my friends got it earlier on, who said it was pretty painful. So it's nice that it's getting easier, and you know, there's work being done on that.
Thank you. And yeah, hopefully we progress to just a saliva collection.
Yeah, we all hope that. Okay, Darwin, you look very ready.
Yeah.
All right, well, take it away.
Yeah, I'm excited. Angela did a good job, so it's a good segue into my presentation. Hold on, let me just find it. Okay. Let's see here. What's that? Bam. Oh, wait, well, you're not supposed to see that slide yet. Okay. Can everyone see it? Everyone good? Yeah, thank you guys for staying awake. And so my name is Darwin. I'm a biomedical engineering student, and my mentors are Michelle Kine and Julia Zakashansky. And I want to express really great gratitude to them, first of all, because without them, I would be nowhere near the level that I'm at right now as far as being a researcher and engineer is concerned. So let's just get started. So just a quick why and why I'm working on this is because, like we've discussed in Angelou's presentation, there's not enough tests. It takes a long time to get your results. It can be really expensive. The quality of tests can improve, and obviously want to increase the accessibility to the public. And so our objective is to develop a portable aptamer-based electrochemical sensor to detect the antigen in saliva. So the project components are broken down into the electrical detection platform, which Angelou talked about, and the portable system and data analysis. But as far this summer, I've been mainly focusing on the portable system. And so just really quick, like Angelou has presented before, we have an electrode that's functionalized with an aptamer and a blocking agent with MCH. And so upon binding with the S1 protein, we get a change in signal. And so far we've been able to get a limit detection of less than 1 femtogram per ml, and which is really, really low and sensitive for the amount of viral load that's present in saliva. And so this is what I've been working on. So all the data we've been collecting has been through a beaker setting and a benchtop model, and that's not useful for anybody. So I've been working on the portable system, which is on the right, where we can attach alligator clips to a portable potentiostat. And so part of the innovation that comes in our technology is based off of Michelle Kind's shrink-dink electrodes. So the reason why we shrink the electrodes is because there's potential to increase the sensitivity and the current density of our signal, which will help in creating a higher concentration range for the antigen. So you can see on the right, before shrinking, the sputter onto our substrate is planar, and then when we shrink it, it becomes wrinkled. And it becomes smaller in size, but the surface area does not change. So we can have a relatively higher surface area in our electrodes relative to the size. And so I just want to break down the mini cell further. So there's 3 electrodes on each substrate: the counter electrode, working electrode, and the reference electrode. So the counter and working electrode you can think of as the anode and cathode. And all the magic is happening on the working electrode. So that's where the aptamers are going on, and that's exactly where the S1 protein is detected. And the reference electrode is the electrode that stabilizes the potential between the working and the reference. And the current is being drawn from the counter to the working. And I put these emojis on the right just because the problems I ran into have been from the counter electrode, which I'll go a little bit deeper into. So when I was first fabricating these mini cells, I ran into a bunch of overload problems, and I pinpointed that the counter electrode just wasn't conductive and consistent. And on the top right, those are overloads of current that I was getting, and you can see the cutoff range. The bottom is what it's supposed to look like. And so a lot of the troubleshooting has been around the platinum counter electrode, and thankfully we've been able to figure that out. So there's 3 factors that played into this. Under the platinum electrode, I also put a gold base layer. I increase the thickness of that, and in doing so, I increase the conductivity of the counter electrode in general. I decrease the platinum thickness because upon shrinking, there is less cracking of the platinum, since platinum is a much more brittle material than gold. And also the warm-up cycles within the sputter machine. On the right is a graph of the change in resistance of the platinum after each cycle. And as I can see, after each cycle, it decreases in resistance, making it more conductive, and eventually stabilizes. And so what I've noticed is that whenever I do more warm-up cycles at higher intended platinum thicknesses, it becomes more stable for each cycle. And you can see on the top right, the different colorations of the counter electrode. The darker it is, the more resistive it is, and the more likely you're going to run into problems. So part of the issue was to figure out how to consistently get the lighter shade of platinum, which is more conductive. And we figured all that out through all these 3 factors. And so here, there's still a lot of fabrication, optimization, and verification to be made, but it's working now. And I'm excited to say that we are starting to functionalize these electrodes yesterday and today, and hopefully we get some good results from that, so that we'll be able to get some data shown straight from our portable system. And as far as the next steps is concerned, I'm just gonna be working on optimizing the whole fabrication protocol, making it cheaper, faster, simplifying applying the AGCL ink, which you can see it can get a little bit messy. And I'll be further verifying the consistency of the mini cell and the consistency of the assay itself on the substrate. And for our future work, we're going to apply this portable potentiostat, which could apply to a phone, which we already have. We already have that in lab. It works with the mini cell. That all works. Now it's just a matter of just getting more data from the mini cell itself. And another one of our teammates is working on a cartridge to work on the microfluidics aspect of it. And this middle thing is the swab that will go into your mouth, and you can insert the sample into the cartridge where the electrodes are. So all the components are coming together, surely but slowly. And I just want to give you a great thank you again to the SURF-IoT faculty, all the fellows, and especially Michelle Kine and Julia Zakashansky. Literally, had it not been for them, I would be no place. Like, they're literally the ones that have opened up all the doors and opportunities I've had so far. So just wanted to show gratitude to that. And yeah, and that's pretty much it. Just some fancy other data that if you're interested in knowing about, it's up to you guys. But that's it.
Well, wonderful. Great job, you guys. Thank you so much. I'm really excited to learn that, you know, this is moving so really rapidly in a direction that is usable for most of the population, and much easier, less painful, hopefully more immediate results. So I'm really looking forward to, you know, hopefully to see that on the market at some point.
Yeah, thank you. That's you know, part of the plans we've been talking about during meetings is to definitely commercialize this, especially as a platform technology. So being under the guidance and mentorship of Michelle kind of definitely been very, very enriching for me and Angela.
Mm-hmm.
So yeah, do you guys have any questions? I can talk all day. I have some, you know, fun facts to throw at you guys.
I actually had a question. Do you know, like, estimated time frame of when you expect the project to be done, or is it just kind of how it goes? Like,
so when you say the project to be done, do you mean like a published paper, or like to be like in the marketplace? So those are two different questions.
Like the marketplace.
For the marketplace, I can't give you a confident answer just because if we had funding, or a lot more funding and all the resources, maybe by next year. Okay. What I will say is also Michelle Kine has been very helpful in getting me opportunities to work with the NIH, and they have a program to accelerate COVID-19 testing, and there are goals to get 8 million tests a day by fall quarter next year.
Oh, okay.
Not from just us, but just from other startup companies in general. And I've seen the companies, I've been in meetings with them, and they're very promising. And I'm glad to say that there's other smart people out there that are working on solutions for us to get more testing.
Okay,
so,
thank you.
Yeah, as far as our project, I don't know how long it would take, but in general, hopefully by fall next year.
Okay, thank you.
Mm-hmm.
You said you had a couple of fun facts. Do we have time for you to share a couple of those?
Yeah, the fun facts was the companies we're working with from the NIH. So there's like one company that has a test that's around 30 seconds, supposedly. They haven't gone through clinical trials yet. There's a lot of talks about over-the-counter use, so there's going to be some tests potentially that's going to be available to take at home. Yeah, and that was kind of the fun facts I was talking about. I just kind of
have like to have that inside track. You kind of get a little insight in before the rest of the world into what's going on.
Yeah, exactly. And so I've been really lucky and fortunate to, and learned a lot from being in those meetings, because I'm definitely like one of the babies in there.
Thank you so much, Darwin. I apologize I had to step out, but I'm back. With Sonia's permission, I can welcome Melinda. Is that who's next? Yes?
Yes.
Melinda, hi.
Hi. Okay, let me go ahead and share my screen. Okay. And are y'all able to see it? Okay, I'm gonna assume yes. All right. So hi, my name is Melinda, and I'm a third-year computer science major. This summer, I had the pleasure of working under Professor Marocha on the IoT application to monitor COVID-19 social distancing on campus. As an introduction to the project, the main goal of this is to reduce the spread of COVID-19 by analyzing social gatherings at UC Irvine. How we do that is we're going to utilize Wi-Fi connectivity data to calculate on-campus occupancy. Using this data, we can do several things. We can explore options to conduct contact tracing of COVID-19. We can confirm compliance to social distancing policies. Lastly, we can adjust the schedule of facilities crew based on the number of visitors in each region. So current contact tracing methods usually use Bluetooth signals that are emitted from everyone's devices. And so once someone's Bluetooth signal from their phone comes in contact with someone else's phone, that will be able to register a contact. However, this method of using UCI Wi-Fi will prioritize the privacy of users. Users do not have to emit their Bluetooth signal. Instead, they will only have to connect to the UCI Wi-Fi, and we will anonymize their MAC addresses. The second pro of using Wi-Fi for contact tracing is that we will be able to produce more reliable findings. For the Bluetooth, users have to opt in to release those Bluetooth signals. However, for this one, users do not have to do anything like that. They just have to connect to the Wi-Fi, and we can use the pre-existing Wi-Fi infrastructure in order to track a larger number of visitors on campus. Lastly, using clear visual representations of occupancy, we can advise policy decisions on social distancing. I want to go more in depth into how we calculate occupancy. So here's a picture of Donald Brent Hall on the second floor. And so each of these green dots with the white text box is a Wi-Fi access point on that floor. So if someone enters Donald Brent Hall on the second floor and they're connected to the UCI Wi-Fi, they will connect to one of these access points. Once they connect to this access point, we're able to track that connection and interpolate that someone entered this floor and in this specific region. If that person then moves to the third floor, they will disconnect from the Wi-Fi access point on this floor and connect to a different one. And we're able to track that connection and therefore that movement of someone walking around the building. However, there are some issues with finding occupancy through Wi-Fi. The first one is that someone may be carrying more than one device. If someone is carrying a phone, a laptop, and a tablet, and all three of them are connected to the UCI Wi-Fi, and they're moving around the building, you will be able to see three separate connections to a Wi-Fi access point, and we may extract from that there are three people entering at the same time. However, it might just be one person with three separate devices. The second issue is that some devices may not be connected to the Wi-Fi in the first place. If the phone is using cellular data and not connected to Wi-Fi, then we can't track their movements through connecting to the Wi-Fi access points. The third issue is that some users may not be carrying their device at all while they're moving around the building. If they leave their phone or laptop in a building while they move around, then there's no way for us to track their connections and disconnections to and from the Wi-Fi access points. The last problem is more of a problem for the Wi-Fi access points on the first floor, but if visitors walk past a building and are connected to the UCI Wi-Fi, they may be able to connect to the Wi-Fi that's inside the building. And so it will seem as if they entered the building when really they're just passing by. So this summer, what I've been mainly working on is collecting a ground truth occupancy data. We currently do have the algorithm to calculate occupancy based on Wi-Fi connectivity, but we need to have the truthful occupancy data to compare how accurate our algorithm truly is. So after testing out several ways, we finally decided to use the video cameras. And so on the screen here is a zoomed in picture of the Wi-Fi access points from Donald Brent Hall, floor 2. And so this is just a region that I focused on mainly for this summer. And so the white boxes represent the cameras 16 and 17, which is the 2 cameras that I used. And the yellow arrows represent what direction the cameras are facing. As you can see, the 2 cameras are able to oversee the 2 entrance and exit points of this region, the staircase on the top right, and the hallway on the bottom left. So using these cameras, you're able to see if anyone is entering or exiting this region. However, there are some issues that needed to be addressed with using this camera data. The first is that each camera has around 31,000 images per day. For this region, that means that there are over 60,000 images to be reviewed per day. And so that's not feasible at all for someone to manually go through them. And so luckily there was an algorithm to process all these images through a filtering algorithm. So that way we can scan for images that only have people in them. And so this was able to reduce the number of images per camera per day to around 3,000 images, which was doable to manually look through. In total, this summer, there was over 800 hours of occupancy collected. And so I want to give you all a look into what the occupancy data will look like. So on the left here is February 18th, 2018, which was a Sunday. And so this is the occupancy graph for one region of Donald Brent Hall, floor 2. On the right is the total occupancy for February 19th, 2018, which was a Tuesday. And this is for the same region. And as you can see, it differs greatly from the weekend to the weekday. For the weekend, the peak was around 4 people in that region, but for the weekday, it reached all the way up to 30 people. And so if we combine these two into and track the end of each hour and compare them, you can see the staggering difference in occupancy from weekday to weekend, but they still follow the same trend of low in the beginning of the day, rising up to noon, and then peaking around early afternoon, and then slowly dropping down. So using this data that I've collected, we're able to compare these numbers to what the algorithm would interpolate from Wi-Fi connectivity data, and therefore improve the algorithm further. So using all the algorithm and everything that's been currently worked on in this project, there are currently live occupancy level interfaces. This one is on the ICS UCI website right now. And so this shows the occupancy levels at different floors of ICS buildings, such as Donald Brent Hall, ICS 1, and ICS 2. And the occupancy levels differ from low, medium, and high. There are some more detailed ones that were also made. So this first one's called occupancy analysis. And so for this one, users can choose a specific building, such as Donald Brent Hall, shown here. And it will show the occupancy rate over time in the bottom right-hand side. Each of the colors for that graph on the bottom right represent a floor and the occupancy rate over time. The second one is called crowd flow. And so this breaks down the number of visits for a particular building, and then by floor, and then by region. The last one is called social distancing. And so this shows the current occupancy capacity across campus for all the buildings we currently have information on. As you can see, we have a few buildings on the left, and we also have them all listed out on the right, along with their current occupancy numbers. And for next steps, we are going to improve occupancy and capacity models with further testing. As mentioned, we're currently testing out some machine learning models, but we're still exploring that field and finding what would be the best method to improve the occupancy algorithm. We will also develop new applications to monitor social distancing in different contexts. As you can see, we have made interfaces in a really broad sense for buildings, but it will be good to create some for different communities, such as undergraduates or research PIs, to better cater to what they would like to see. We will also work to appropriately encrypt data and securely notify those who have been potentially exposed to COVID-19. That way, if someone lets the system know that they have been tested positive, we'll be able to let others know that they may have been potentially exposed without revealing the identity of who originally was tested positive. Lastly, we are trying to expand this implementation to other nearby organizations. That way, if we do know that someone has been tested positive, we can share that encrypted information with other organizations so they too can let their patrons know that they may have been potentially exposed. I would like to take this time to acknowledge my faculty member and all the members of the research lab. I would not have been able to do all this research without them, so I would like to thank them very much. I would also like to thank the SURF-IoT faculty and fellows for making this such a successful program and letting me take a look into what research really is. And thank you. And are there any questions?
Invite questions.
Yeah.
Miriam, we haven't heard from you.
I did ask Darwin a question.
Oh, you did? Okay. That's what happens. I step out.
But I think Melinda did a really good job. I found it really interesting how they, how you guys did the cameras and how you guys detected people. I thought that was really interesting because when you brought it up, I was like, are you gonna go through all those pictures? Like that seems really difficult. So I thought that was pretty interesting.
Yeah, thank you. It was, yeah.
I wanted to add on a little bit, asking about the cameras, just in terms of so as you mentioned before, if you just were to go off of the Wi-Fi, what devices are connected, you could have duplicate devices on a person, or not carrying it around. So at this point, then, are you primarily doing a number of people on a floor just using the phone, or just using the cameras while using the Wi-Fi just for locations on the floor? Or is it a mix of the two to be able to find a good balance in determining the capacity?
All right, just to make sure I understand the question carefully, is it what people I'm tracking using the cameras? Is that correct? Or
whether the tracking the people is currently just being used by the cameras, since they can accurately determine who has entered and left the building, or if it's still incorporating then the Wi-Fi, even if it might not be as consistent with its accuracy.
Oh, okay, I see. Yeah, so the Wi-Fi is the main method. The cameras right now are just mainly for validation purposes to improve the algorithm itself.
Okay.
Does that answer your question?
Yeah, okay. Because
yeah.
So then, in that case, then, what are some of the ways that you're able to use to be able to validate whether or not, let's say, someone is having two different devices that have Wi-Fi capacity? Is it just, I'm just interested in knowing how you'd be able to do that.
Yeah, that's a good question. I think it's one we're currently tackling, and that's what I was mentioning for our next steps is the graduate student I'm working with, he was looking at using some machine learning models to just see maybe if there's a trend or a pattern in terms of connections happening, to see, oh, if these two devices are always connected at the same time, do they belong to the same person, or is it just two people who always walk around together? So there's still a lot to explore in this field and to see what exactly is the best way to go about it, because it is a hard problem. Sometimes people don't connect to the Wi-Fi and there's no way to track them, or they have many, and so it's just a matter of exploring and see which one works best.
Okay, thank you.
Yeah, no problem.
Thank you, Melinda. Again, we're proud of you. Sharon, I'm sorry, you want to say something?
Oh, just a quick question. I was wondering if you had any thoughts about how this sort of technology might be used post-COVID.
Yeah, so I think in the beginning when I mentioned scheduling facilities, I think that's the biggest one that I think really impacted me when I first thought about it. Because if you think about it, maybe there's a lot of people who visit a building at a specific time. Maybe it's good to know, oh, maybe we should sanitize things. Even after COVID, I think it'll be good just to keep that in mind. And
my first thought when I was looking at it, I thought if you had a really large firm with lots of different disciplines and you wanted to see maybe how they collaborated with each other, you could almost watch which departments kind of travel over to other departments. It seems like it has a lot of possibilities for different use to get information.
Wow. That's definitely an interesting thought. Thank you. I think you're correct. I think it can expand to other non-COVID related topics, just because it is just tracking people moving around. and that can be used in different ways. Thank you. But yeah.
Thank you, Melinda. Again, we're proud of you.
Thank you.
Speaking of Miriam, are you ready? Yes?
Yeah.
The floor is yours.
Okay, let me just play with the settings really fast. Okay, you guys can see my screen, right? It's like loading. Yeah, okay. So hi, my name's Miriam. Over the summer and since the beginning of this year, I've been working with Elizabeth Pena along with the ABO Lab. And over the summer, we started working on the project on the validity of administering child language assessment virtually. And so given the abrupt shift to online learning and teaching, our project aims to evaluate the validity of testing children online. And when we often think of testing children, we often think of like testing their knowledge on a certain topic, but that's not really what we're focusing on. We're focusing on something a lot more critical, like diagnostic testing. And so we're doing this to see if we can find any children that have potential disabilities, and from there give them support and services that they may need. However, with COVID-19, there's been delays and cancellations with these diagnostic testings. So if you think about it, there's kids that don't have support or may not know that they need the support. So then we come across the bigger problem: how do we actually test these children when all these kids are at home doing school virtually? So for the pilot study, we did 2 different phases. So phase 1, I interviewed speech language pathologists, also known as SLPs, about their experience with online assessment. And then phase 2, from there we went on to compare children's scores when tested in 2 different conditions. And so hopefully you guys can see my cursor. So this is the face-to-face, and this would be when the assessor is in the same room as a child. And the virtual condition is when the child is alone in the room and it's getting delivered via Zoom. So for phase 1, I interviewed SLPs to have a better understanding about their virtual experiences, how they changed their testing approach, and what challenges that they encountered. And so when I was like reviewing their responses, I saw that there was a lot more challenges that they encountered than successes. And some of the bigger things that I saw was the visual engagements, because typically when you do the test normally, you just have to present a picture of the child and ask them a question, but we can't really do that right now since it's virtually, so it has to be more game-like. But then an SLP brought up that it's a lot more difficult than that, because you have to make sure that they're focused on the test as well as the making sure it's not just a game. So we went on to technical challenges. Of course, since it's virtually, everyone's gonna experience any problems like that. And then we also have ethical and privacy issues. And then the bigger problem that they brought up, which is focused on our project, is since they are at home, how do we know that their environment is the same across every single child? So when their test results, we need to make sure it's valid and accurate enough. And then they did bring up some successes with virtual testing, which is it's easier to record and get responses and score them a lot more quicker, because it's not on paper and you have to transfer them online. And so for phase 2, this is where we spent majority of the summer. So we went from paper to online format. We used Qualtrics, and then taking the responses that we got from phase 1, we did these different consent forms to make sure the parents and the child understand that their privacy and ethical issues are being handled. And then we had tech checks to make sure we avoided these technical difficulties. And then we balanced protocols. So by that I mean we wanted to make sure that in both settings they had equivalent test items, and that at the end of the study that we would have when they're randomized into either a virtual or face-to-face first, that we got like a 50-50 in both settings. And then the kids in the study are bilinguals in English, Spanish, and or Vietnamese. And of course, every project comes with problems. So in the very beginning, when we started running through the thing, we realized that we had audio quality wasn't the best. So we used Qualtrics. And then, sorry, I'm like super nervous already. Hold on. Sorry.
Miriam, you're among friends.
Yeah, sorry.
And we're all here to support you. So please.
Yeah. Sorry, I'll continue. Sorry.
No, don't be sorry.
So as I was saying, sorry.
Yeah, you did beautiful work, and we're all your cheerleaders, okay?
Thank you. So,
No, please.
I like lost my words. So when we were doing the testing in the very beginning, no, go back. The audio buttons weren't properly working. So we had to make sure that the assessors knew that they had to size their screen a certain way. And then the biggest problem we probably encountered was about an hour before the first testing session was the links that were being generated by Qualtrics. They weren't actually properly working. So say I'm the parent and I do the consent form on my phone. And then, okay, day one testing session, they open it up on their laptop, it would restart the whole session. So that was like a really big problem. We had to reconfigure a lot of things and recode like a good majority of the project to redo everything. And we were already in the middle. And then when we actually started, we realized that the participants would get really frustrated, like the little kids, which is, I mean, it's understandable. They're little kids. They don't really want to do this. And so we actually got permission to show you guys a little clip. So fair warning, I was told that the audio might be a little loud. So just be aware of that.
These men have mustaches, and these men
don't have mustaches at all. No.
She likes pizza, and what about her?
She doesn't like pizza.
So yeah, this was in the virtual setting. You can see that she's alone in her room by herself, and then she's getting tested by somebody else in a different room. And so since we weren't able to test everybody because everything got delayed, we were able to test 2 different kids. So child B, you can see that they got 100% on both settings. And so that's pretty good. And then child A, they did a little worse in the virtual setting, but the percent right here is about 4%. So it kind of shows that we can get similar results in both different types of settings, but I can't really say that significant, statistically significant yet because we haven't tested all the kids. And then so in the future, since I am a junior, I'm going to continue work on the project. So we're going to do this with 20, 30 kids. We're going to continue fixing any bugs that come up, and then from there see how we analyze and draw the conclusions like I did before, but with a lot more kids. And then if it does show to be effective, we want to make sure it's available to all these SLPs. And before I end, I just want to give a big thanks to everybody in the Audit Lab, specifically Professor Pena, Amy, Giselle, Lisa, and Javier. And if anybody has any questions, I would be glad to take them.
Outstanding. Let's invite folks to ask questions.
I have one question too. It occurred to me when I was watching the video of the little kid giving the response, and I wondered if it was adorable. And can you get any additional information by watching reactions, or are you just gathering if they answer the question? Does that make sense?
Yeah. So by watching their reaction, we can maybe also see if they aren't really understanding it, because there are some, because I watched the whole clips, and there's kids, they're like, what? And then you have to repeat the question to them. So maybe if they don't get the answer right the second question, that might be a big indicator that they're really not understanding the whole question, if that answers your question.
Yes, but when they normally do this in person, is it just one facilitator, one therapist there, and she or he gathers all the information just from observing it? They don't videotape anything, or you know what I'm talking about? Do they just kind of mark it off? Because if you have this, and it's another thing that just occurred to me when watching it, you could go back and see, is the child looking off to the corners, looking down? Are they extra shy? Or are there other things besides just understanding the language, to where if you're just in there in person, you might not pick up on that information. But if you go back and review, you can say, they've improved from 6 months ago. Look how much more engaging they are. Look how much quicker they respond.
So in a normal setting, they are recorded, just audio.
Okay, I see.
But I can't really answer because I'm not an SLP to the second question. I would assume that you can pick up a lot of hints on their body language, because when I was like watching it, like I'm not trained to do that, like to understand the whole language, but I could tell, like I could pick up on some little things. So I'm assuming there are some things you could pick up with the recording.
Thanks.
You're welcome.
How do you feel, Mariam?
I'm good. I think I had like a little panic attack in the middle. Public speaking is not my thing.
But don't you feel great that you feel
that it's over?
after presenting?
That it's over.
You feel like, I'm proud of my accomplishments, I'm proud of what I've done. And this is a reminder for all of us that this is the beauty about these presentations, is that it's almost like you feel like you're bringing things to a closure, right? And now you're ready for the next opportunity and more exciting things to do. So from the bottom of my heart, we wish you well, Mariam, and hopefully we'll continue to hear more successes that you have accomplished, and also the rest of you. Thank you again.
Thank you.
Can we give another hand to Mariam, please? Very good. It's now my pleasure to turn it over to Yuchang Chen. Yuchang. Okay. Vikram?
Yeah, sure. Can you guys hear me?
Yeah.
Let me share my screen.
You know, Vikram, can I take just a couple of seconds?
Yeah, go for it.
And Miriam, there's something personal that connected me to what you and Professor Penny are working on, and I can chat with you offline. But anyway, I am emotionally touched by the beautiful work you guys are doing. Okay? So,
thank you.
All right, Vikram.
Is the slides visible? How about now?
Yes, perfect.
All right, cool. All right. Hi, everyone. My name is Vikram Maryala. I'm a third-year computer science student here at UCI. My project this summer was building a privacy policy engine for the TIPPER system, and I was advised by Professor Nalini Venkata-Subramanian and Dr. Roberto Yus. So what is TIPPERS? TIPPERS is an IoT data management system for smart spaces, which facilitates the development of IoT applications. It's currently deployed at UCI, and we're basically collecting a bunch of data from various sensors around campus, and then translating that into application consumable data. For example, as Melinda talked about earlier, using Wi-Fi access points to gather the location of people, as well as the occupancy of various buildings and rooms. And then using using that data to then monitor for different regulations, for example, COVID-19, like COVID-19 social distancing regulations, or pretty much anything that we could use occupancy data for. So my particular portion of the portion that I worked on this summer was creating the concept of policies within the TIPPER system. So that's basically defining allowing users to control what data others can see, what data of theirs others can see. And by default, all data is secure and private. So if there are no policies defined, nobody will be able to see your data. So why privacy? There's a lot of private and sensitive information that needs to be protected around the world. Just knowing your data is protected just gives people a sense of security, the same way knowing your house is locked gives you a sense of security. And it keeps data out of malicious hands from potential terrible situations. And then furthermore, there's a lot of upcoming legislation to help protect individual privacy. For example, in Europe, there's the GDPR, which is a European Data Protection Act, as well as CCPA here in California and several others around the world. It also allows users to be informed about how their data is captured and how much of it is stored. For example, we can have someone define a policy saying, I don't want my data stored for more than 1 month on a particular company's server, or I don't want the particular company to have any of my data like stored. So it allows users to be in full control of their own data. So here's the tipper's data flow. It's just how the policy engine interacts with the tipper system. So the data flows from right to left on the system. So we have users on, so we have people on one end, and then sensors gathering various data from them. And then that is passed through a preliminary policy engine that's implemented outside this tipper system that controls what data is passed into the system. And then it goes to another policy engine where we check for we check deletion and retention policies to see if we're allowed to store that data or how long we can store that data for. And then it's added to our database right here. And finally, it's passed through when users are trying to access the data through various applications, it's passed through our access control policy engine, which is the main sharing policies that I'll be talking about. And it filters the data out, so only that has been deemed like the user, like only that users have deemed necessary to share is available for everyone else. So the primary policy that I'll be talking about is a sharing policy. So sharing policies control what data applications are able to access. For example, Sam, user 1254, can use my data on application contact tracing when I, user 123, am at Donald Bren Hall between 8 a.m. and 7 p.m. This English statement is then translated into a JSON model, which is present right now. It's kind of I don't want to go too much in depth on it because it gets really verbose, but once we have this particular model, it's easy to filter out the right data for other people to see. The next type of policies that we have are deletion policies, which control what data is being stored within the system. Again, we have an English statement right here: do not store my data when I am at links in library, and the corresponding JSON model for that. And then finally, we have retention policies. So it allows users to control how long their data is stored within the system. For example, I don't want my data to be stored. I want my data to be stored for only 1 month when I'm at science library between April 22nd, 2020 and July 30th, 2021. And again, the corresponding JSON model for it. So what I worked on the policy engine. So I modified the Tipper's Java API to enforce sharing policies. So doing this, I modified the query to gather observation data. It started off as just a simple select all from a particular observation. And I appended each policy to the end of the observation. So you get something similar to what we have here. And then this just allows it, so it filters out all the observations that policies don't satisfy, or that don't satisfy policies. Furthermore, I added the concept of retention policies. There's a sleeping thread within the system that wakes up at midnight every night and removes all the relevant data, as well as something similar for deletion policies. We have a toggle option so that when data is added, it can be either be deleted immediately, which suffers, like, it doesn't help the performance of the system, or we can do it all at once at night. So here I have a quick demo. So this is all the data within the Tipper system at the moment. This is all kind of old data. It's just for testing purposes right now. So now let's see what happens when we have an empty, there's no policies defined within the system. This token right here is it allows, it's basically an authentication token through an application. And as you can see, no data is returned when there are no policies defined. Now let's try defining a policy within the system and see what happens. Oops. Sorry about that. All right, let's see what happens when that policy is defined. All right, now that we have a policy defined, let's see if there's any data that's returned. Again, I'm going to execute the same query again. And as you can see, there's an observation that corresponds with the particular policy that I added to the system, and that's now returned. Now let's add another policy to see what, for more data to be added to our query. Now we have more data within the system, and because of the second policy, there's 2 more data points that are added because of that. Now let's try deleting one of the policies. Let's try deleting observation 10 right here using the deletion policies. So when a deletion policy runs, it first goes through and deletes all of the observations that are corresponding to that particular policy. So when we run this policy, it should delete that observation when we try it again. All right, and now as you can see, that observation is no longer present. So let's try it again, and this time let's add a retention policy. So I'm going to add a policy to say, let's keep observation 5 for 1 hour. So I have information corresponding to observation 5, and we'll keep it within the system for another hour after that policy is added. All right, so the retention policy has been added, and let's see if the observation is still there. All right, it's still there, which is good. So I'm gonna skip ahead a little bit. It takes a while for the retention policy to hit. So I went in and changed the system time within the thing, within the system to check for the, to apply the policy. And during that time, my my access token was revoked. So I had to refresh my session. And as you can see, that observation is no longer present. And we have just the one policy that we have to, that we have access to at the moment. Or sorry, the one observation that we have access to. All right. So conclusion and future work. So the TIPR system requires a policy engine to comply with the various legislation, and we currently only have applications for aggregated information. For example, occupancy. So that's a number instead of particular person is at a particular location. So it does not release info about individuals. Furthermore, we want to I was able to design and implement the policy engine that supported the 3 types of policies that I mentioned and integrate it within the TIPR system. This allows us to define, to create applications for identifying specific people. For example, a contact tracing COVID application where you can see where a particular person is at a given time and trace where they were over the course of months or a couple of weeks. And because they're giving you consent to see their data, it's legal in essence, because it's their choice. And then future work would be like show the user that the data has been completely deleted from the system, instead of just like having them believe it because it's not, they can't see it within the queries. And then we want to create a user interface for people to define policies instead of having to define JSON models for it and adding it to the system instead. And then a slightly more efficient way that we can implement the filtering of observations is through a data sieve. I didn't have time to implement it in total for the currently, but in the future I really want to keep working on that. And yeah, I just want to thank Professor Venkat Subramanian and Roberto for all the help this summer, and just want to thank the SURF-IoT team for all of the encouragement as well. And that's about it. Thank you so much for listening. Any questions?
You can stop sharing if you like.
Yeah.
Questions?
I had a quick question just in terms of how users would actually be interacting with this policy. So in turn, like, what is the anticipated way for users to be able to set their policies for how their data is used? Like, is it expected that each app that they would be using that uses the tipper system would have its own like settings page that they can determine it, or is there some larger like access point for users to inputting their own limitations?
Okay, so we want to have like an application dedicated solely for defining policies, and within that you can define what application can access your data. That's part of the UI I was talking about. It can get kind of complicated with the number of parameters within each observation. So it took some time to develop that.
Okay, so then what would be, I'm just interested in like what would be, for example, if someone is just visiting campus, they're using the Wi-Fi, which might be integrated with different tipper like applications, like the location tracking stuff. So is there like a set, like a plan for a default policy that would be like a safe choice in terms of legislation, in terms of privacy?
So the default policy would be that we can't access their data.
Okay.
So it's like, yeah, it's better.
It's opt-in rather than opt-out.
Yeah, exactly.
Okay, that makes sense. Thank you.
Thank you so much.
Okay, thank you.
Very good. Our last presentation is going to be a group presentation. Jackson, Shuyang, and Jinhua. The floor is yours. Who would like to start?
So I think Jerry will share us the screen.
Right.
For the demonstration part?
Oh, no, just the PowerPoint.
Sorry, where's the link for that part?
I can share the screen.
Yeah, go ahead.
Oh, sorry about that. Can you all see the screen?
Yep.
Yes, go ahead.
Okay. Hi everyone. So my name is Shuyang Zhang, and my teammates are Jason Jiaxin Luo and Jerry Xinhua Zhou. Our professor is Dr. Fangan Zhang, and our project is on remote hearing tests for elderly patients. And just to give you guys a quick intro to our project. So we are focusing on the condition called hearing loss that's prevalent in almost 30% of the elderly US populations. And it is a common disease that associates with aging related tear and wear. And for the hearing aid tuning process, the traditional method is to do in-person clinical visits, which can be troublesome and time-consuming in current situations. And there are multiple online tests that have been working on providing such follow-ups online, but they have their own downsides. So through our project, we want to provide a remote and online platform that both user-friendly and provide meaningful data for the patients and the doctors. So our solution, after reviewing multiple papers on the previous work that have been done in the teleaudiology topics, we decide to use the following procedure. And we will show a demo at the end. So let's first take a look at the core of our sort of project. It's the 2AFC Link 6 sound test. And the Link 6 sound test is first used to evaluate the hearing ability of children who has hearing aid and cochlear implants. This test is relatively short, but it has a universal phonemes that covers a broad range of frequency that used in normal speeches. And we can combine the test with the two alternative forced choice method to increase the test sensitivity. And so our implementation is to have two audio stimulus for each trial. And one audio will be empty and one will be the audio file with the phoneme in it. So we will ask the user to choose which one they hear. And this way we will prevent a false positive result. And next we will let Jason to talk about the calibration.
Thank you, Shuyang. So getting into the real test, one problem we found is how are we gonna calibrate the hardware to our test? Because as we know, our platform is not restricted in any hardware. So we need to set a standard that is most correct for like for phones, for PCs, for tablets. So we need to have a comfortable hearing level of volume control for all of the devices. So basically what we have done is we ask the user to set the volume of a certain sound to their most comfortable volume and set that as the standard for all of the other sounds. And into some research, we found out that high frequency hearing loss for elder patients, as shown in the right picture, is the main cause of hearing loss. So this is an audiogram for an elderly patient. And we can see that for the lower frequency sounds on the left, most elderly patients are actually have normal hearing or even just a mild hearing loss. But getting to the higher frequency range, things get worse and they experience moderate or even severe hearing loss in the higher frequency range, such as 4,000 and 8,000 frequency range. So by looking in this audiogram for an elderly patient and the Link sound test speech banana on the left, we found out that it is reasonable to use a lower frequency 500 Hertz aw sound for control to test higher frequency sounds. So basically, if they know that they can hear the aw sound comfortably under a certain intensity of volume, then if they cannot hear some higher frequency sounds, then they probably know there is something wrong with their higher frequency sound detection abilities. So next slide, please. And also there's another thing that we wanted to tackle, which is the data recording. So since we have a web-based application that collecting patient data is vital for future research. So we decided to sort the patient data in a Google Sheets shown below. So basically we show how many correct answers they have got out of the 3 tests we'll be doing for them, and when the test is done. And we have implemented the recording process into a question for the patient at last, which is shown on the right picture. We not only take the patient's names, but we also pair the patient's response with their correctness. So you can see on the right, we have 6 sounds in the Ling sound test, ah, yi, u, sh, and sh. So we basically test 3 times for each sound, and we record the correctness of the patient response. And then we pair this result with the patient's name and store it in the database. And then we show the response correctness to the patients, as you can see, 2 out of 3 or 3 out of 3. This is a test run I've done for the sake of demonstration. And next slide. And also, so we'll next invite Jerry to do a demonstration of our Ling 6 sound test.
Okay, thank you, Jason. I'll share my screen now. So upon starting the application, we will be seeing the web app. Everything will be working, will be running on the client side. So the test will not be disrupted by internet connectivity issues all the way until the submission page. That's something that relies on internet connectivity, but up until that page, everything is running on the user's browser or mobile phone's browser. First, we'll see the instructions to ask the user to find a quiet room for the next 5 minutes. And then we'll be seeing the calibration page where the user choose a sound that the sound level that they're comfortable with. This is a process to make sure that the default volume wouldn't be too large, and when the user is using something like a headphone, that wouldn't damage their hearing. In the next stage, the sound is going to be coming from either interval 1 or interval 2. And the user is forced to make a choice over here. And there are going to be 3 rounds, and for each round, there are going to be 6 sounds played. So for each sound, the user make the best choice. If the user make the wrong choice, it's going to appear red. And of course, if the user make the right choice, it's going to appear green over here. As you can hear, there are, each time it's a different sound. It's gonna be like we talk about, the sound of ah, yi, u, si, shi. For each round, the sounds are going to be randomized. So the sequence you're hearing will not be different for each round. So we are reaching the end of round 2, and there will be just one more round to validate the result, and then we'll be going through the submission page. I intentionally made some wrong choices so that we can see in the end result how the patient performs. since you may probably not be able to hear every sound coming from the intervals, I definitely recommend you to just visit the URL to take a look at the website. Eventually, we'll be getting a result over here. You'll be able to submit the result or just not submit the result and using that just as a reference. Suppose if you submit the result over here and typing your name over here, it's going to call a Google API and to basically place the result in the Google Sheets we have over here in the next level so that the provider can easily collect the data the user has. The application is written in React. It's a popular web framework. And upon starting the application, it's going to go through a certain of phases. It's going to start with the welcome screen, go through the prompts and validate, and basically set the volume that user prefers. It's like a factor, and then going through 3 trials, eventually showing the result. For each trial, it's controlled by a test site, and inside is going to go through 6 different sounds. The 6 sounds we pre-recorded over here with the volume state we previously the user indicated. And for each individual test, it's going to be controlled by the test case JavaScript, and eventually be showing the prompt and also having 2 sound buttons for the user to click to choose the sound they want. Eventually in the result page, we are going to display the result and also calling the Google API that we have for the sheets to be able to record the result. Thank you, that's the demonstration.
And any comments or questions? Feel free. Thank you, everyone.
Thank you, guys. Any questions?
I had a quick question just in regards to the sounds that are like the false, or like the sounds that didn't make any noise to try to trick the participant, just in case they weren't able to hear it. Are all those sounds like the same default, like regardless of which vowel sound is being made? Are the other sounds, or is the other option always the same file?
The other option, it's always the same file, yes.
Because I just noticed while looking at the demonstration that there seemed to be sometimes a noticeable difference in duration of the clip, which just as a possible thing to consider, whether it might be worth trying to make like the wrong choice to make it be the exact same length, just so that there aren't any other factors that could influence the decision that they make. So that it's not like if they can't hear it, it's not a 50-50. It like to prevent it from having other factors that could sway them towards making the right decision.
You're absolutely right.
Something that I noticed.
Yeah, you're absolutely right. The intention is to have all the sounds, including the blank sound, having the same length, and we'll definitely double check and to verify that.
Okay, yeah, I could be wrong. It just when looking at the demonstration, it seemed there was something I noticed, like, oh, the sounds usually were a little bit shorter, while the wrong sounds seemed to be pretty consistently the same length. So just something to consider.
Yeah, good point. Absolutely, we'll double check.
All right, thank you all. Again, if we can turn the cameras back on. So just want to take a few minutes to, again, congratulate the fellows on your wonderful accomplishments. And I know there's going to be many more to come. So we're proud of you. Can we do a clap for the fellows, please? Yeah. And as I mentioned, we're always indebted and grateful to the faculty mentors for everything that they have done. And I know Professor Pena is with us and others were with us throughout the day. They work with the students. So can we also give them a hand, please, for everything that they have done. This is really the essence and the beauty about UCI is this mentoring experience, and where this lifeline mentor, or this full circle of mentoring. Faculty mentor postdoc grad students, they also mentor undergrads, and then eventually undergrads, they might become faculty, or they might become, they'll be mentoring others, and so forth and so on. So, and that's the beauty about a healthy society, is that we continue to solve problems, we continue to discover, we continue to do what's in the best interest of society and humanity. So I wanted to take a few minutes and invite you to reflect on a few things. So I guess we can start by, I know this was a challenging time with the pandemic and so forth. How, and again, this is, if you want, is everybody comfortable to continue recording, or should we stop recording? It's up to you. Should we stop recording? Yes? Okay, let's stop recording.